Hello, everyone, and a very good morning to all of you. Distinguished delegates, presenters, and participants from SAARC member states and other regions around the globe. Ladies and gentlemen, I am very thankful to all of you for joining us in our first SAARC webinar in the year 2018. Firstly, I would like to introduce myself. I am SN Javed and I am working at SAARC Energy Center as a research fellow renewable energy for the past 4 years. I shall be moderating this 2-day session of the SARC webinar, the aim of which is to disseminate the findings of the SARC study report on use of submersible turbines in canals and the assessment of its resource potential to the policymakers, regulators, researchers, academia, and other stakeholders from the member states. The study report was conducted last year by Dr. Nawaz Akhtar, who is one of the renowned and most famous experts of hydropower sector in South Asia region. And we are very blessed to have him with us today. Yesterday, we had covered topics ranging from introduction, various types, technologies of hydrokinetic submersible turbines. Then we had a session on the selection of site for hydrokinetic submersible turbines, assessment of resource potential for those selected sites. The presentation was given by the expert Dr. Nawaz Akhtar. Then we had a brief session on the best practices and productive utilization of micro hydropower projects in northern areas of Pakistan by GIZ Asif Farid. Then we had a presentation from Dr. Karl Komsi, Smart Hydro Germany, on the application of these technology in cooling canals of thermal power plants. So with this, I would like to start this today's session. I am extremely grateful to all our elite panel of experts such as Mr. Asif Farid, Dr. Irfan Yusuf, Mr. Ehsan Marwat, Dr. Karl Komsi, Mr. Tomaso Morbiato, Mr. Asim Shehzad and Umar Mukhtar for their enthusiasm and eager willingness to participate in our webinar. I shall introduce them in detail before the start of their relevant session. Ladies and gentlemen, you will have the opportunity to ask questions to presenters by typing your questions or clicking to the raised hand option into the attendees pane of the main window of GoToWebinar software. You may also send in your questions at any time during the presentation. We will also collect these and address them during the question answer session at the end of each presentation. Today we have agenda which includes first we will have a presentation by Dr. Mohammad Nawaz Akhtar on the planning for installation of hydrokinetic submersible turbines. Then we have a presentation from we have a short interview which was recorded earlier on commercial aspects of hydrokinetic submersible turbines by Mr. Trey Taylor from Verdant, USA. Then we have a presentation on the simulation studies for the installation of multiple turbines by Mr. Asim Shehzad from Institute of Space Technology. Then later we would have a presentation on design concepts of hydrokinetic turbines and their performances in variable flows by Mr. Tommaso Morbiato of Wind City, Italy. After the break, we would have session on the business perspective of hydrokinetic submersible turbines by Mr. Malik Nadeem Awan from Pakistan. And later, at the last, we would have a policy challenges and regulatory framework session on the development of hydrokinetic turbines by Dr. Irfan Yusuf from Alternative Energy Development Board, Pakistan. At the last of the session, we would have a brief session on knowledge sharing. We would request all the participants to take part in that session by giving their comments, their reviews, and overall recommendations to us. And we will wrap up today's session in the conclusion, recommendation, and closing of webinar in a short session. So with this, I would like to give mic to Mr. Dr. Akhtar Nawaz for his presentation. Let me introduce Dr. Saab very briefly. Dr. Saab is a professional mechanical engineer with masters and PhD in hydrogen fuel cell technology. He had conducted the same study to assess the resource potential and planning for a demonstration project using using run-of-river submersible water turbines. He has extensive experience in the designing, coordination, in fabrication, installation, and commissioning of power plants. His professional strengths are mechanical designing, engineering management, technical procurement, technical inspections, R&D in the areas of renewable technologies, especially fuel cell technology. He holds 5 publications in national and international journals and a lot of conference paper. So, Dr. Saab, we would now listen to you on your presentation of planning for installation of hydrokinetic submersible turbines. So, over to Dr. Saab now. Dr. Saab, are you listening to me?
Yes.
So you can share your screen and continue with the presentation.
Assalamu alaikum and very good morning to all of the participants. I welcome you all from the SARC member states and all over the globe. And today we will share the planning phase for the installation of submersible turbine or similar projects. So, planning for installation of a submersible turbine, we have divided into 7 topics and we will go through all like general planning and planning for procurement, planning for transportation, planning for installation and commissioning, including standard reliability test, planning for performance monitoring and operational life, planning for consensus building among stakeholders, planning for provision of electricity to users, and general planning for the installation of 5 kilowatt submersible turbine. As we have already discussed yesterday, that we have a model turbine of 5 kilowatt developed by Smart Hydropower Germany. So we have 3 sections. First is Upper Jhelum Canal. We have to consider that its running period is 11 months over the years, and 1 month it remains shut down for cleaning and maintenance activities. Then we have to consider planning for annual shutdown because this is the only available time for working under the canal, on the canal bed or under the bridges, and that is planned is 1 month, and it starts from 5th January of every year, and the canal again continue running on 5th of February. So we have generally 1 month for any activity within the canal. So we have to plan our all activities accordingly. Number 3, we have planned schedule of activities for the installation of this turbine at Jagu water level crossing in Upper Jhelum Canal, and we have planned it and presented in the form of Gantt chart, and we can see it now accordingly. Now this is the Gantt chart, we have made it. So we spread all activities so that we can complete within 1 month, and that is from 5th of January to 5th of February. So first activity is transportation of turbine to the site, and that might be completed up to 1st of January. And then we have to mobilize the EPC contractor, which is engineering, procurement, and construction contractor. And he has to mobilize and all along with his accessories, tools, equipments, and whatever he needs, he has to manage on the site up to 4th of February. So canal will be shut down on 5th of February. So that time should be available for the installation activities. So we can see here that 5th of February to 5th of 5th of January to 5th of February, it is the shutdown, and we show it through red color. So now the lowering of turbine into the canal might be completed up to 6th of February, 6th of January, sorry. And we should lower it with the help of mobile crane or whatever tools and tackles EPC contractor may utilize for this activity. And installation of the turbine holding structure should start from 7th of January to for completion up to 10th of January. And then installation of turbine may take up to 2 days, and we have to complete all the installation of the turbine accordingly up to 12th of January. Then installation of power lines, circuit breaker, control panel, smart meter, etc. That activities may start from 13th of January to 16th of January. So in this time, we might complete all such activities. And hookup of control panel to the utility circuit breaker may take from 17th to 19th of January. So in this way, we have 3 days for this activity. Then pre-commissioning testing. So pre-commissioning testing activities, we have 3 days for this activity. So up to 22nd of January, this activity might be completed. Then is commissioning of the system. The whole system should be commissioned within 2 days, and that means that up to 24th of January, we have to complete all such activities. Then is the canal start, then commissioning of the system, and we have also 2 days for this activity, and then test run, canal start running on 5th of February as per planned schedule. So start of the system, we will check that the system is running all as per plan. So we have only 1 day for this activity. Then reliability test run will be checked, and for this, the 72-hour, for this 72 hours, we will check all the systems, equipments, and accessories as per planning. They might be functioning normally and as expected up to the mark, and we will continue recording up to 72 hours. That up to 72 hours, everything is as per plan or as expected from all the equipment, systems, and everything. So if it is okay, then handover and inauguration ceremony. So on 15th of February, we will hold an inauguration ceremony, and the system will be handed over from the EPC contractor to the owner of the turbine or system of the project. So this way, we have planned all activities to be completed within 1 month time. And now, the first activity for going to install a project or a power project in a situation which is governed by Punjab government, who has made Punjab Power Development Board to facilitate the implementation of power generation projects and power distribution arrangements in case of power sale to a private sector. So be reminded that up to now we have achieved a license from the Punjab government for only demonstration purpose. So presently this turbine can be and will be installed for demonstration purpose only. So Punjab Power Development Board also pre-qualify the sponsors both in case of raw site projects or solicited site projects. And this board is also meant for to evaluate the bids of pre-qualified sponsors and issue letters of interest and letters of support to the successful sponsors. And is also to assess the sponsor project company in seeking necessary consents, permissions from various governmental agencies. They also help to negotiate the implementation agreements, assist in the negotiations relating to the water use licenses, and assist the power producer or fuel supplier and provincial authorities in the negotiations, execution, and administration of other agreements such as PPA, FSA, and so on. Sorry. The PPID board is meant to coordinate with the federal government agencies and DISCOs, NTDC for development of the power generation projects, and to follow up and assist in the implementation and monitoring of the projects. Also, they help to take up such other matters as may be required for the promotion of power generation projects in the provinces. The hierarchy of implementation policy they have made, we have presented on the next slide. This is the hierarchy designed by the development of power projects under Punjab Government Authority. They have divided into two categories. They handle in different departments. First is any project, either it is wind, hydel, renewable, biomass, biogas, or like this, less than 50 megawatt. If the capacity of such project is less than 50 megawatt, they have a different department. And if the project capacity is greater than 50 megawatt, either it is fossil fuel, coal, gas, or hydel. They handle it through a different department. And this is the downside distribution of the projects and the flow chart that AEDB, that is Alternative Energy Development Board, PBIT, Punjab Board of Investment and Trade, and Punjab Power Development Board. So they handle it and assist in all activities. Either it is raw site or it is for registration available, or purchase and submission of SOQ, evaluation, approval of PPIB, and so on. And if the project is greater than 50 megawatt, that will be handled through PPIB, and it starts from solicited site and how the advertisement will go on, how the receipt of pre-qualification requests, documents, and so that all activities should be organized. And for that activity, every activity they have given plenty of time and also fixed that in 30 days or 60 days or 15 days, whatever activities that should be completed to speed up the all the activities and processes should be organized, and no undue late may come into action. So Punjab Irrigation Department has issued permission for the installation of above mentioned turbine for non-commercial utility at the designated site, and a copy of this permission letter we can see here. They have issued for the demonstration activity only, and no commercial aspect may be in it. So now, number 2. This was the prerequisite we have discussed so far. Now we will consider planning for procurement. So international limited tenders will be floated for the supply of hydrokinetic turbines for the whole canal, mentioning like specific parameters of the canal and the required quantity. These things will be accordingly published and advertised. Quotations will be requested from following 44 hydrokinetic turbine manufacturers all over the world. First of all is Smart Hydropower GmbH, Germany, whose model turbine we have in Pakistan. Number 2 is Thornton Energy Services, UK. Number 3 is Alternative Hydro Solutions Limited, Canada. Number 4 is Energy Alliance, Russia. Number 5, New Energy, Canada. Number 6 is Tidal Energy Private Limited, Australia. 7 is Lucid Energy Technologies. And number 8 is Seabell International Company Limited, Japan. So in this way we have Electric Energy Limited, UK, Green Tech Avenue, USA, Canada, and Germany. Kirloskar Integrated Technologies Private Limited, India. ACEP, Alaska. Verdant Power, USA, and so on. Full list of 44 manufacturers and developers can be available. So to save the time that is limited, we will go on to next. And if any one of you needs the full list, we can send it to you by email later on. So now we will see the criteria for the evaluation of quotations, because when we receive the quotations, we have to evaluate accordingly. So we will consider following things to evaluate the most suitable turbine for this site. First is maximum power output at the given velocity of water in the canal. And number two, cut in velocity. Number three is cut out velocity. It means what minimum velocity will be at which the turbine starts functioning, and cutout velocity means the maximum velocity of water at which the turbine may stop working for safety of the turbine. So then is efficiency curve, means at what velocity level how much output power will be available through which turbine. Then is price, also very important parameter. Then ease of installation, how much infrastructure is required and all other difficulties may be involved. Then stability, how much stable is turbine in this situation. Useful life, either 15 years, 20 years, 25 years, how much we have to consider. Then the performance history. We might like to know that its history, how it performed, in which areas, in which conditions, and how much power it produced so far, and what is the experience of the owners of the turbine or the project where it was initially installed. Then reference projects, how many projects it was utilized, and financial aspects through this turbine, and after sales service they experienced. Number three, planning for transportation. Transportation of the turbine from the dry port to the site of installation will be carried out through the expert transport company, and unloading and transportation to the designated site of installation will be carried out by EPC contractor using mobile crane. Number four, planning for installation and commissioning, including standard reliability test. Installation plan to be provided by the manufacturer and will be followed accordingly. Number two is commissioning of the turbine will be carried out strictly in line with the instructions provided by the manufacturer. Then, after commissioning of the turbine, a 72-hour standard reliability run test will be carried out as per SOP made by ISCO, that is Islamabad Electric Supply Corporation, pursuant to their standard practices. We will go into detail next. Now, we came to know that what administrative procedures in the project may be followed, that we have to abide by accordingly. Actually, administrative procedures clarify the role of all participants in the organization. Once the role of these parties is identified, a plan for the turnover of equipment systems from the contractor to the owner should be developed. During number one, schedules of construction, number two, completion dates, and number three, testing. So through these three phases, we have to identify and accordingly organize the administrative procedures that may come across among all the stakeholders, which are three generally. First is project owner or owner of the turbine. Number two is project engineer, and third is the EPC contractor. So all the activities among all these three stakeholders, they will be defined and administered accordingly. So we have to account for all such procedures. Number one, owner of the turbine or project. Owner is usually the operator and provides also operating personnel and maintenance personnel that may coordinate, supervise, participate in installation and commissioning program. The owners review administrative, construction, installation, pre-operational and operational programs and schedules accordingly. Number two, they witness testing activities as necessary in support of the commissioning program. Also, they provide coordination with off-site operating, dispatching, and transportation and agencies as required. They also accept equipment and systems for operation during the pre-commissioning testing phase. Number five, they also accept equipment, systems, and will facilitate subsequent to successful testing of these items and provide final acceptance of the project. Number six, they operate all permanent equipment and turbine to support the startup schedule and make final decision in areas of disputes relating to test activities performed during the testing programs. So these activities will be handled accordingly by the owner or its representatives. Now, the second major stakeholder is the EPC contractor, because a lot of work is to be performed by this stakeholder. And EPC contractor provides first engineering of the project. Number two, procurement. He might plan, organize, provide support through all procurement process. Number three, construction. That activity is to be wholly taken up by the EPC contractor. And number four is installation activities. So this activity is also to be carried out by EPC contractor. Then is testing equipment and systems under the contract witnessed by project engineer and owner, because he has to coordinate and make all decisions as per administrative procedures and under the guidance and coordination of these two. The contractor will perform following all engineering activities like selection of the turbine and associated luxury auxiliary systems. Number two, coordinate procurement activities and transportation of all of the equipments from the dry port to the installation site. And he has to prepare Gantt charts and schedules of all sub-activities from start to completion of the project. And he has to perform commissioning and testing of the equipment. Number six, he has to record test data results during construction, installation, and pre-commissioning testing, and will distribute to the project engineer and incorporate into the system turnover package. Number seven, EPC contractor has to implement tagging and work clearances on systems and equipment. Number eight, EPC contractor has to give schedule of completion of the construction work and test activities to support the overall commissioning program. Number nine, EPC contractor provide the project engineer with status of contractor furnished equipment and systems deficiency list items as well. He has to perform pre-commissioning testing on contractor furnished equipment and systems in accordance with test requirements contained within the contract. Now the third stakeholder in a project is project engineer. So project engineer typically provides the design documents to install and test the turbine based on the manufacturer's recommendations. And project engineer provide all engineering documents and information necessary for construction, completion, and testing of the turbine. He has to assist other engineers on site to provide assistance on design and engineering programs accordingly. So these are the three main stakeholders who work in coordination with each other. Now we consider the pre-commissioning test. Number one, pre-commissioning test is to ensure all tests and checks necessary for each system to be functional before startup of commissioning testing of the overall integrated turbine commences. Number two, the purpose of these procedures is to verify that each system performs in accordance with design requirements. Number three, excuse me, commissioning test procedures will be used during the final phase of the plant startup. Number four, these procedures outline tests to be performed on turbine, generator, and controls, voltage regulator, excitation systems, relays, and protection equipment, and the various modes of starting, loading, and stopping each unit. Number five, this phase will be coordinated with the vendor's representatives supplying the turbine and with the operating authority for this turbine. So this is pre-commissioning test. And following tests will be performed in support of the commissioning program and in keeping with the schedules for pre-operational and operational testing. Number one, unit alignment. Number two, rotational runout checks. Number three, rotor diameter measurement. Number four, rotor roundness measurement. Number five, stator bore diameter measurement. Number six, stator roundness measurement. Air gap, air gap measurement. Number eight, verification of temperature devices. Number nine, current transformer polarity checks. Number 10, stator and rotor winding resistance measurements. Number 11, open circuit saturation test. Number 12, short circuit test. Number 13, phase sequence test. Number 14, heat run, overspeed test, and rejection tests. So then we come to commissioning of the turbine. Installation plan for the turbine provided by the manufacturer will be followed, and commissioning of the turbine will be carried out strictly in line with the instructions provided by the turbine manufacturer. In case of unavailability of commissioning procedures for this turbine or any other, following tests will be conducted. Number one, speed no load rejection. It means when there is no load on the turbine, so turbine will reject the power. Then number two, 25% load acceptance and rejection. It means apply the 25% load on the turbine and same as then reject it, and turbine should be normal. Then 50% load acceptance and rejection, then 75% load acceptance and rejection, and then 100% load acceptance and rejection. It means if 100% load is applied, everything should be running normal, and if 100% load is rejected, then everything will be running normally, and then normally shut down. And number 7 is, after the successful installation and commissioning of the turbine, a 72-hour standard reliability run test will be carried out as per made by ISCO pursuant to their standard practices. Now we will see what it is actually. For this test, the whole system will be operated continuously for 72 hours, and all critical parameters mentioned in the table we will see in the next slide, means voltage, current, power factor, power, frequency, RPM, stator winding, temperature, etc. will be recorded after every hour and daily signed by EPC contractor, manager construction, and owner and client of the turbine. If due to any reason turbine go into shutdown, then again 72 hours will start from 0 hour to confirm reliability in continuous operation. So now we will see what it is. Now this is the acceptance form. and plant design, procurement, and construction, and it will be signed by all the stakeholders. Here is date and all required description. Now, this is the log. It is to be filled for 72 hours. From 0 hour to 72 hours, it will be recorded and signed by EPC contractor, manager construction, and client or owner of the turbine. So here we see that how phase-to-phase voltage, phase-to-phase current, power factor, and total power, frequency, and kVAR and RPM, stator winding temperature and general temperature, turbine VRG temperature, and grid voltage all are recorded for 72 hours and signed by every stakeholder. Number 5, planning for performance monitoring and operational life. Number 1, the plan for the periodic performance monitoring and preventive maintenance of the turbine will be adopted as supplied by the manufacturer of the turbine. Number 2,
Dr.
as
Saab,
the
excuse me, may I intervene? Dr. Saab, you have less than 3 minutes to finish your presentation. I would request you to just speed your make swift presentation now.
okay, so these are the steps we have to consider during the planning phase, that how we will do what activity and in which manner. So number 6 is planning for consensus building among stakeholders. This is also very important. Following 8 are the stakeholders for this project or in other projects may be similar. First is Sarkozy Center, who has planned this activity. Number 2 is IST, Institute of Space Technology, who is academic institute and also coordinating in this project. Then is MS Al Awan General Trading Corporation, country head, smart hydropower, and owner of the turbine so far. Number 4 is Department of Irrigation, Government of the Punjab, being the owner of the canal. Then is Punjab Energy Development Board, who is also administrator authority. Then is ISCO, Islamabad Electric Supply Company. Then is Ministry of Environment, Government of the Punjab, and representatives of the local area. These are the 8 stakeholders. And sharing of this study report with all the above mentioned stakeholders will be carried out. And also, a one-day dissemination workshop will be arranged at the site, and like all stakeholders may be invited to build the consensus. And finally is planning for provision of electricity to users. So luckily we have office building of hydro monitoring station with the connected load of 3 kilowatt just at a distance of 100 meters from the site of installation of turbine. Number 2, the output of the installed turbine may be consumed within this public sector office. Number 3, in the premises of Jagu Head, there are a number of installations whose security and monitoring activities demand uninterrupted electrical power supply, which can be met through the output power from this turbine for 11 months annually. Number 4, for the coming projects on this site, electricity consumers all around the area facing more than 12 hours load shedding, and that they will be eager to utilize this electricity produced from the turbine we are planning to install. And the beneficiaries may also include small scale industrial units. So this is all over regarding planning phase of this project, and I welcome all of you if you have any questions, and thank you for giving the time and listening and sparing this spare your precious time for this activity and your interest in this regard. Now the mic is to the Mr. S. N. Javed.
Thank you very much, sir, for your very comprehensive and detailed presentation on a very important aspect related to this technology, which is planning and installation of hydrokinetic submersible turbine. So I would briefly recap what Dr. Saab said about something about the general planning, which included detailed Gantt chart prepared. Then he also spoke something about the local government licensing and approval required from agencies for implementation agreements, PPAs, environmental approvals. Then he touched the topic of procurement planning, which included detailed tenders, documents, and the requirements of the canals and the manufacturers of the international turbines manufacturers. Then he touched on the topic of criteria for evaluation of these tenders, which included the parameters such as velocity, price, stability, system life, performances. Then planning installation phase includes the standardized reliability test On the administrative procedure side, Dr. Saab spoke about the contractor to owner shipment procedures, completion dates, testing of those turbines. Then he spoke something about the responsibilities of the owner, EPC contractor, the commissioning of turbines, and later at the last stage he spoke something about the planning for the consensus among the relevant stakeholders, which included the professional government authorities and the relevant manufacturers and the owner of the turbines. So, Dr. Saab, thank you very much for your presentation. It was wonderful to listen to you and a very detailed topic. So, the question has arrived from one of the expert, which says he has not mentioned his name, but the question is, which parameters are measured in hydrokinetic turbines in the reliability test run?
Yes. So generally, for the stability of the turbine, the first thing is the voltage, then is current, and the variations, if any, due to the fluctuations in the flow of the stream or due to unbalance created in any way in the turbine generator that may come out in the form of these two parameters. First is voltage, then is current, and third is the frequency. If the velocity of water varies, it affects all three parameters. So we need constant frequency, and however we will monitor and also made it constant from the rest of the electronics through power conditioning unit. But for the stability of the turbine, we should know and monitor and close observation on it, that how much the load variations are coming out in our display panel. Voltage are stable, current is same, and frequency, what happens with it. So this shows the stable performance of the turbine.
Thank you very much, Dr. Saab, for your very detailed answer. So we have a question from Department of Renewable Energy under Ministry of Economic Affairs, Bhutan. The question is from Chotan Duba, who has asked a question that apart from requesting the quotation from the manufacturer, was the visit of to the manufacturing unit form the part of the activity of the developer as well? So, to my knowledge, Dr. Saab, correct me if I'm wrong, but normally these projects, due to the simplicity of these projects and due to the small scale of these turbines, the manufacturers are normally not required to visit the site in advance. So all of these things are done by the project developer themselves. So am I right, Dr. Saab, in this one?
Yes, you are right.
Perfect, perfect. So I think we have answered the question from Chotan Duba. So we move on to our next question, which is, in case some canal and rivers does not have any dry days, so is it possible to do installation of these turbines in those areas where they don't have any dry days?
Yes, the type of turbine we have in Pakistan that is made by Smart Hydro, this model, which is called the floating type submersible turbine. The beauty of this turbine is this, that in any condition, on any duration, this turbine can be installed during the running of the canal or river through the help of a mobile crane or any other facility over there. This turbine can be installed anywhere in any location with the help of a mobile crane or similar provision during the running of canal or river.
Thank you very much, Dr. Saab, for your very detailed replies. I think we have some more questions, but due to shortage of time, we will shift these questions into the at the end of the our session, which will be a knowledge sharing session. So we urge again all the participants to ask questions, to write questions back to us. We are going to address them during this, hopefully in this webinar session. So, Dr. Saab, again, thank you very much for your very detailed presentation, and I thank you very much, sir.
Welcome. Assalamu alaikum.
So, ladies and gentlemen, now according to our schedule, our next schedule is on the commercial aspects of hydrokinetic submersible turbines. And the main person responsible is Mr. Trey Taylor from Verdant, USA. And Mr. Trey Taylor has done a pre-recorded interview with Renewable Energy World magazine, and we had requested him for the short interview. We thought that it would be very informative for all the participants, and the interview is available with us. We would like to play this interview right now for you. So if you have any questions, we would then send these questions to Mr. Trey Taylor, and he hopefully he would be replying us back in 1 to 2 days time. So now I would shortly introduce Mr. Trey Taylor. Mr. Trey Taylor is the Director of Verdant Power and President of Verdant Power International Incorporation. Trey Taylor co-founded the Verdant Power, a New York-based company, in 2000. Previously, he founded the Interactive Marketing Institute, working with AT&T, Oracle, Compaq, Kodiak, Deloitte, and Tosh. Uh, Baltimore Gas and Electric Company, and Price Waterhouse World Utilities Group. Prior to that, he held senior management positions at Edison Electric Institute, ITT Corporation, and Procter and Gamble. He currently serves on the Renewable Energy and Energy Efficiency Advisory Committee for the U.S. Department of Commerce and New York City's Green Export Initiative Advisory Council. He also served on the board of directors for the Hydro Research Foundation, chaired the R&D committee for the National Hydropower Association, and has helped charter the Ocean Renewable Energy Coalition. He is also a founding member of the American Council on Renewable Energy and recently founded Anchor Coalition, a project of the Ocean Foundation. So a very well experienced and very elite expert in the field of hydropower sector. And thank you very much, Taylor, for agreeing to provide your interview to us. So, ladies and gentlemen, now we are going to listen to Mr. Trey Taylor's interview.
Hi, I'm Russell Ray, Managing Editor of Power Engineering Magazine. We're here in Long Beach for the Renewable Energy World Conference and Expo. With me here today is Trey Taylor. He is the co-founder and president of Verdant Power. Trey, thank you so much for being here.
My pleasure.
Trey, your company recently received the first ever license from the Federal Energy Regulatory Commission for a pilot, a tidal power pilot project in East River. Can you talk a little bit, describe that project for us?
I'm happy to. It's quite significant because it's a historical event to receive the very first commercial license for a tidal power project in the United States. Significant in the sense that it's taken us nearly 10 years to get to this point. The licensing process itself is pretty short. It's about 1 year. And the Federal Energy Regulatory Commission has been wonderful in their support of this new technology and projects in the sense that they streamlined the process. However, preceding all of this was about 6 years of permitting and environmental studies to get to the point where we are today.
A lot of work, a lot of trials and tribulations to get to this point. Can you talk a little bit about some of those trials and tribulations, the testing that you needed to do to get to this point?
Yes, and it wasn't easy because it's a combination of not only having the money to be able to do the right kinds of tests, and we began with a technology that was actually approved of back in 1995 by the Department of Energy, and we put our team and resources behind advancing that technology through a 3-phased testing project in New York, beginning in
मुझे बंद हो
to working prototypes need to be designed, built, and put into the water. So part of that is a pretty onerous regulatory process we have to go through in the United States. And I think that's one of the biggest reasons, along with money. Where we were lucky is working very closely with universities because the original design came from New York University and New York Power Authority. So that helped us get to where we are. And then secondly, the support we're getting from the state of New York itself, the New York State Energy Research and Development Authority. So it's a combination of the support from the city of New York, the state of New York, the universities, funding. Now that's not easy to bring those kind of coalitions together.
Tell me a little bit about the turbine technology itself. How does it work?
Our turbines look pretty much like wind turbines.
Yeah.
Now, the wind industry really never took off until all the technologies began to converge on three-bladed upstream axial flow rotors. Right. What we have is a three-bladed downstream axial flow rotor. And what we use, the nose cone, the front part, is to orientate the turbine toward the water current. So in the case of a tide in East River, and East River, by the way, is a tidal channel that connects Long Island Sound with the Atlantic Ocean. So the turbine is able, and passively, like a weather vane, is able to turn around and get the ebb and the flood tides. So that's how our system is designed to work.
And you spoke at a session earlier today, a very well-attended session about ocean tidal stream power. You mentioned that the turbines in the East River would be offset. And how many turbines are we talking about, and why would you offset? Talk a little bit about the design of that.
How we came to that conclusion was inadvertently.
Yeah.
We had used some existing modeling based on wind turbines on how to space these turbines. Yeah. And here's what I mean by that. The kinetic energy in the water current flow, if we're taking a percentage of that energy out, you need to allow enough distance for that water current to restore itself before you take another percentage out.
Right.
Otherwise, it's like the path of least resistance. That water current will start moving around your turbines, and you're killing the goose that's laying the golden egg of new energy. So here's what happened. Our first 6 turbines we put into the water were 3 rows of 2. Yeah. Now, the blade design is absolutely beautiful, and I can elaborate on that if you like later, but the materials we used weren't strong enough. So our blades broke. And it's a slow cascading effect. So we had 1 rotor break, 1 turbine break, then a second one, and then 2 days later, the next row. So what we're able to do is see the effect of 1 turbine on another, and then 1 row on another. And by that, we realized how we better can arrange these turbines so we're not interfering with that water current with stronger rotors. That led to our new design of deployment, which is putting these on a tri-frame. So we know the exact distance from side to side and forward to aft. But each tri-frame then is offset with one another with the proper distance to allow the water current to flow and not regain its speed before the energy is taken out.
Well, clearly a lot has been written about your success in East River. Can you talk a little bit about other places where you plan to deploy and test this technology?
Well, we are. We're looking, we're up in Canada right now, and with the support of the Canadian government, we're looking at a project on the St. Lawrence River. Now, what's nice about river projects is the water current's always flowing. The beauty of tide, although it's intermittent, has a capacity factor between 30 and 40%. It has a very high capacity value. And by that, I mean the reliability and predictability. Con Ed would look at this as a source of distributed generation. Yeah. And liking it because they could look at their clocks and a tidal chart. They know exactly when the tide and power's coming on, when it's going off for the next 200 years. That's predictability of tides. In the rivers, there we have a capacity factor of maybe 60 to 70%. Water current's always flowing in the right situations. And so that can act as a base load dispatchable power. And so there's a real value for marine hydrokinetic applications in river systems. So another project is in Canada. What we'll have are 2. We'll have a project that's in East River, which shows distributed generation, the high capacity value. And then we have a project in the St. Lawrence River, which shows base dispatchable power using the very same systems. But
base load power.
Base load power because of the high capacity factor.
Well, I'm sure there have probably been studies about the tidal power potential worldwide. Do you have any stats on that?
Several good figures on that. The Ocean Energy Council predicted that estimated there's about 63,000 megawatts of tidal power in the world. Now that's just tidal power, right? If you then look at river potential, right, when you add the 2 together, there's probably a potential of close to 250,000 megawatts of potential hydrokinetic power around the world.
Incredible. Clearly, there's a lot of promise. There's a lot of progress being made. You're one of the few companies that have had real success, and we sure do appreciate your time and insight, and we look forward to seeing all the results of all your hard work. Thanks so much for being here.
And thank you very much. I appreciate the time.
So it was wonderful listening to Mr. Trey Taylor. Actually, we had some problem with the video and the audio issue, but we would request all the participants that if you are really interested in listening to Mr. Trey Taylor short interview, you can visit our website at the end of today's webinar. We are going to upload all the presentations and along with this short interview to our website more at the earliest by Monday morning. So you can go access this interview. If you have any questions specific to Mr. Trey Taylor, you can send us back your questions. We will address them through his reply later. Otherwise, if you have any questions, you can send us those questions in text, in email. So we will address those. So we have like one question from one of the participant. Uh, we would like to address this question on one of the participants has asked the question that what is the most critical aspect of planning for selection of the site, and with me I have Dr. Shoaib Ahmed, the acting director of Sark Energy Center. I would request Dr. Saab to quickly give us a short reply to this question. Dr. Saab, over to you, sir.
All right, thank you, Essen. Well, as you asked that, okay, my answer should be quick. So I would say the most critical thing is the selection of the site. Okay, and while selection of the site, what are the, I mean, again, I mean, inside the selection of site, what are the most critical criterions to be looked into? They are the water resource, water speed, and the availability of the water, and uh, also the water should be clean enough, so that clean means that it should not have any foreign objects or any debris in it. And secondly, the user of the electricity produced should be close enough. Okay, this will help to have keep our electrical system or the laying of the electrical wiring and other things. It will help us to keep that electrical system more simple. So these are the two criteria which should be looked into while planning to install any submersible turbine. All right, thank you very much. I hope I am very clear.
Thank you very much, Dr. Saab, for your very brief reply to the question. Actually, our next speaker is Mr. Asim Shehzad, and he is going to get online in just a few 1 to 2 minutes time. So, in the meanwhile, I will like to throw one more question to Dr. Shoaib Ahmed just to take the opportunity of this time available to us. So, Dr. Saab, we have a question from Mr. Nameez Musafir, who is from Sri Lanka, and he has asked a question that you mentioned about stakeholders. What were the social and environmental safeguards made and social and environmental concerns clearances addressed? And I hope he's concerning the same technology or the same project. So.
All right, Asian, thank you very much. Well, first of all, my reply has two portions to it. First portion is what was done during this study. Okay, please remember this study was a prototype project. It was a prototype, and we did it as a role model for actual deployment, right? So in doing so, we had a very safe conditions there, and because we are doing for the first time, so we wanted to have very close to ideal type conditions in which these concerns were, I mean, the least, they created least botheration for us, because the user was a government department, all the installation and the canal was also administered by the government department, and as we had the backing of government of Pakistan while doing this study and this prototype installation, so these we did not really face these problems. However, when the general public or the other people will do it in the real life in real time, in that case, of course, this is going to be a problem. First of all, whosoever has the control over the water resource, some arrangement must be made with him, right? If the owner of the turbine and the owner of the water resource are the same, then it's not a problem. But if you are trying to use a water resource who is under somebody else, naturally some sort of arrangement has to be made in terms of whether the electricity produced or whether in shape of some rent to him or whatever. Secondly, in case there are some uh, more than, I mean, some population around the point of installation, and if you are trying to give uh, electricity to one of the users and not to the others, right? This may create some sort of rift between that small community who is either willing to use this electricity, and some of them uh, may be trying to I mean, go negative or go against this type of installation. That these are the two major things which I could foresee, that okay, these could be the social aspects which should be looked into. However, their environmental impacts or environmental things are so negligible, probably they will not be have any major impact on the overall project. But in case, depending upon site to site, if there is any, so whatever the nature of that environmental impact is, I think the remedial actions can be taken then and there, whatever the situation is. Thanks.
Thank you very much, Dr. Saab, for a very detailed answer on the social and the environmental aspect. I hope that Mr. Nameez Musafir has been satisfied with the reply. If, however, you still feel that you need to get more detail out of this, you can send us your query or you can send us a back-to-back question, and we would definitely address them during this webinar if we find any slot of question answer session, or otherwise we could reply you back later on after 1 to 2 days time. So in the meanwhile, I think that we have some difficulty connecting with Mr. Asim Shehzad. Sometime all the participants must appreciate that the getting online with these things takes some time, a little bit issues of technical and technical nature. So we would continue with our one more question we have received from the participant, and I would throw this question to Dr. Saab, Dr. Ahmed Saab. Dr. Saab, there's a question on what should be included or what is included in the pre-commissioning testing. I think this is a very important question before the installation of a turbine. Any pre-commissioning testing required for this project? Like in case of bigger project, definitely there is required pre-commissioning testing. So are these projects required these kind of testing or not? Over to Dr. Saab.
All right. Thank you, Yasin. Thank you for putting this question. First of all, let me clarify that, of course, pre-commissioning, if carried out, is beneficial and is one of the requirements. But at the same time, I would like to mention that because the nature of the technology and because the small size of the technology, please remember this pre-commissioning is not as complicated or as big as it is in some bigger projects. So please take my word that this pre-commissioning is quite easy. However, in pre-commissioning, two things which in my point of view, I think is more critical. They are, first of all, whatever the installation structure you are making and whatever the installation requirements are, they should be ensured that they are strong enough and there shouldn't be any weakness in that. Secondly, in pre-commissioning, please do check all your electrical system, because this is electrical system is outside the canal, and there is this involves laying of the cables, laying of the, let's say, converter, and these, I mean, few more components. So please make sure during pre-commissioning that your electrical system is fully installed. It has all the requisite components. It is fully secured. and things like that. So these are the two things which are critical in pre-commissioning. Rest of the things, I mean, do not carry that much weightage in my point of view. Thank you, Esan. Thanks.
Thank you, Dr. Saab. Thank you very much for your detailed reply on the specific query raised by one of the participants. And we urge all the participants again and again to feel free to ask any questions, any basic question, any expert question. We have the panel for you. They are going to reply to those queries very shortly. And in the meanwhile, I think we have Mr. Asim Shehzad available with us. We are going to check if he's available. So let me go towards his presentation topic. In the meanwhile, our IT team is going to connect him with us. So the topic of Mr. Asim Shehzad in the simulation studies for the installation of multiple turbines. This Mr. Asim Shehzad was one of the expert who worked on this project with Dr. Akhtar Nawaz during the study. So I will briefly make an introduction of Mr. Asim Shehzad. Mr. Asim Shehzad is a faculty member of the Department of Aeronautics and Astronautics Institute of Space Technology, Islamabad. He had conducted the simulation studies for the installation of multiple submersible turbines in Ghazi Barota Canal, as well as participated in related activities regarding installation of submersible turbines. So I think Mr. Asim Shehzad is ready for giving the presentation. I would hand over to Mr. Asim Shehzad now. Mr. Asim Shehzad, am I audible to you?
Ji sir, you are audible.
Yes, I think Mr. Asim Shehzad is audible. His presentation is visible to us, but I may request him to maybe turn on his mic. Mr. Asim, if you can listen
Sir,
to
am
me,
I
please
audible?
can you turn on your mic? We cannot listen to you now.
Sir, can you listen to me as I am able to hear? Hello.
So, ladies and gentlemen, in the meanwhile, since he is trying to correct his microphone, I would like to urge the participant. There were some queries related to how they are going to ask questions. Some of the participants were a bit confused as to how to ask the question. So, you have the opportunity to ask questions to presenters by typing your questions or clicking to the raised hand option into the attendees pane of the main window of GoToWebinar software. Once you are connected with the software, it's pretty similar to what kind of software we normally use, like Skype or Viber. So you have this option available. You can just click the raised hand option, and then I will come to know that you want to ask question, and I will ask the question directly from the presenter. Otherwise, what you could do
मैं
is there's
बोलता हूँ
also a
दोबारा आप friendly
chat
setup
window at the below side of the software. So I think you can also type in your question in that chat box, and we are going to address that. And I'm going to
Hello.
inform for the consumption of all the participants that the presentations will all be uploaded. The short interview will be uploaded on our official website, which is www.sargenergy.org, and you can also send your query clarification later on. So thank you very much, Mr. Asim, for your agreeing to participate in this webinar. I am very afraid, and I'm apology in front, but you have some limited time available. Our next presenter is going to get online in next 15 minutes. So over to you for presentation. Thank you, sir. Excuse me, Mr. Asim. I guess the audience cannot hear you. Um, I think I think there is some kind of an technical difficulty going on with Mr. Asim Shehzad's computer. Let me check out with him for a minute. In the meanwhile, we have some more questions from the audience. So let's address them till we have Mr. Asim Shehzad online. Mr. Asim Shehzad is going to correct his problem. So over to Dr. Shoaib Ahmed Saab. Sir, Dr. Akhtar Nawaz earlier spoke about the environmental approvals and the administrative approvals required from the relevant agencies like government bodies and the honors. So, do you see the same type of difficulties faced in this technology comparable to the bigger projects like dams and run-of-river projects? Just to have your view on that one. Over to Dr.
All right, thank you, Asad. Well, knowing the size of the turbines and the type of, their installations and their use, in my point of view, although these things do exist, but they are so minimal that one need not to be worried about these things, right? However, in case these exist on a very specific site, right, those should be addressed then and there, depending upon the nature of whatever the objection has been raised. But generally, this technology has its application in a very small sizes, which is like say 5 kilowatt, at the most 10 kilowatts. So in those cases, these things are not as big, or these are not as serious as they are in case if you are going to have a let's say micro or medium size hydro turbine installation, which I would say anything which is more than 50 kilowatt or 200 kilowatt or say. So in this technology and the sizes we are talking about in this webinar, they are so small, uh, so that the seriousness of those environmental permissions and those things, they are very minimal. But of course, these things have to be catered for if there is any requirement. Thank you.
Thank you very much, Dr. Shoaib Ahmed, for a very nice reply on the aspect of the environmental approvals and the administrative approvals required for this technology. So I guess we are still facing difficulty connecting with the Mr. Asim Shehzad. I think we would have some time connecting with him. In the meanwhile, I would urge again the participants to take this as an opportunity and ask as many questions as you want to know more about the technology and the application of this technology in the perspective of specifically SAARC member states. So let me take this opportunity myself to throw a question to Dr. Akhtar Nawaz Saab. Dr. Akhtar Nawaz Saab is sitting with me. So, Dr. Saab, what do you think poses the financial implication or cost of the turbines relevant to this technology? Do you think the cost will come down with a period of time, since this is a very novel technology, a very new one, and the cost are still the payback period is very amazing and very astounding. But do you see that in future the cost will come down with the help of indigenous development or indigenous manufacturing? Over to Dr. Saab.
Yes, thank you, Mr. Hassan. Of course, the cost of the turbine will come down, and gradually, as the commercial manufacturing, commercial installations increases with time, the cost will definitely come down. Even we have this observed, the smart hydro has 50% of the turbine at present, the prices they experience so far within 8 years of time. So now the more and more companies are coming into this business, and the exploration of more sites are done in the coming years. So with this, as commercialization of these turbines will go on, prices will come down as the manufacturing and the number of companies will increase with time, day and day. And this will also exploit the new areas of development associated with this technology. And with this, the availability of associated components and materials will be available throughout the world, and the local manufacturing, trading, installation will speed up. So this will decrease the cost of production, transportation, installation, and commercialization as well.
Thank you very much, Dr. Saab, for your reply to that question. So we have one more question. We would keep asking the question. We have a lot of questions being asked by the participant. So we would take this as an opportunity to keep going on with this question answer session till we see if we could get connected with Mr. Asim Shehzad. In the meanwhile, Dr. Saab, there is a question from India. Mr. Sharma has asked a question that what do you see the potential of hydrokinetics turbines in India? We know that they also have the same type of canal systems in Pakistan, and in my opinion, I mean, from a layman point of view, I think there must be a huge potential for generation of electricity through these canals and these rivers. So over to Dr. Shoaib Ahmed Saab for his views on potential of hydrokinetics in India, sir.
All right, thank you, Essen. Well, I would like to say yes, there is a good potential for these technologies to be deployed in India because straightway, whole of the Indian Punjab have a very good canal system. So, or naturally, that is most suitable for this type of technology. Other than the Indian Punjab, there are many other areas, and most of the India has good, I mean, good canals or small low speed nalas, right? So this technology holds a good potential into that. Apart from India as well, in other SAARC countries as well, it holds good potential for that. So I think it has fairly good potential. But remember, its potential, we do not consider it in terms of the electricity produced because this technology is for the small applications. So in those applications, wherever the population is very scattered and it's distributed near or close to the canals and the rivers, and they laying the national grid to that area is difficult. So in all those cases, this technology will prove very, very useful. All right. Thanks, Asim.
Thank you very much, sir. I think I would like to interconnect this with another question. We have just received a question from delegate of Bhutan. He has asked a question that how do you address the variation in velocity flow speeds of different canals for the same model of turbine? To specifically redefine the question, I think he meant by that is it that one turbine can be installed in all the sites, or do you have to be designing the turbines based on specific sites? Over to Dr. Shoaib Ahmed Saab.
All right, thank you. I think it's a very good question, and many people may be having this thing in their mind. Please remember the overall usage or overall installation of this technology is in two phases. One is the turbine itself, which is inside the canal, which is responsible to generate the electricity. And secondly, it's electrical system, which will take this generated electricity to the user, but in that format which is useful for the user, right? In the electrical system, there is a component which will stabilize whatever the output is coming. If the voltage or the power is going down, right? So electrical system can compensate for that type of a thing. And electrical system can be different from depending upon the whatever the output we are getting from a particular site, right? In case if there is a requirement to have the backups to cover up the electrical variations, maybe a small battery can do that, or otherwise electronically also that is possible. But of course, whatever you add on to it system, it slightly increases your cost as well and the complexity of the system. But I agree there are means and technical ways to compensate for the variation in the speed and the variation in the output of the submersible turbine. Thank you.
Thank you very much, sir. So let me get back to Mr. Asim if he is available. Mr. Asim, can you hear me now? Mr. Asim Shehzad, am I audible to you?
Hello, Ji, Assalamu alaikum.
Ah,
Yes, sir,
good
I can hear
morning,
you.
Asif Shahzad. Finally, we caught you, sir. So,
Yes, sir,
Mr.
you are
Asim,
audible.
yes. So, I would request you to be very brief in your presentation. You have to finish it in 10 to 12 minutes time. We are already behind the schedule. So, if you can quickly go ahead with your presentation, sir. I think now you may be
Thank
able
you.
to share your presentation now.
So, Assalamu alaikum.
Walaikum salam. Please go ahead, sir.
Assalamu alaikum. I should start with the name of Allah. And so I hope all these sessions were great and informative. So I would just try to my emphasis on the modeling and simulation studies of submersible water turbine, and why do we need to actually simulate the submersible turbine in an open canal. Bismillahirrahmanirrahim. So actually, as you all know, the technical specification of a smart hydro turbine, which was available to us thanks to Mr. Nadeem Saab, who imported this turbine from Germany to Islamabad. And before installing it in a canal, we ran some simulations to verify the output and the flow characteristics of this turbine. So what we did is we actually made a CAD model of this turbine, which was the first part and which was the difficult part, as we have to take many measurements and we use 3D scanners for the blade modeling of this turbine, and we modeled different parts of this turbine. So the challenge that this involved in this was to precisely model each and every part of this turbine, as it was difficult and it was a really challenging task to model the debris protector and propeller. And then the meshing of this whole turbine was a difficult part. After the meshing, we want our solutions to have the maximum fidelity and to represent the real life conditions. And we have to cater for the solution instabilities arising from numerical dissipation, numerical dispersions during the simulation of this turbine. So we modeled this propeller of the smart hydropower turbine using the 3D scanning techniques, and finally we were able to make this propeller. These are the different views of the propeller and the dynamo, the connecting rods. So we made different parts individually, and then we assembled these parts of the turbine together. Then the diffusers, base plates, floats, and the debris protector. So it took us around 6 months to make a CAD model of this turbine as accurate as possible, and after several iterations, we were able to make mimic the actual CAD model. And after this CAD model, we actually modeled the whole section of a turbine, and a flow domain. The black box in which the turbine is actually mimicking the water. So it has different conditions, different input conditions. Like from this wall here, as my cursor is, this wall is the water inlet wall, and the back portion is the outlet wall. and the lower wall is a friction surface which will represent actually the bed of a river, and the side walls are also the, the stationary walls, but the upper wall is a moving wall which is representing a flow, a moving flow. So these are the dimensions. The section is 18 meter wide, 9 meter in height. These are the dimensions of Kazi-Brotha Canal, and we assume a 30 meter long section. So the water will enter from here, and we will be able to see the results of flowing water on the turbine. We were able to calculate the drag force the water will exert on the turbine, and which the velocity variations and the pressure variations throughout the cross section of the turbine, and of the lateral distance in which the flow will recover its properties, like how much after the turbine the flow will recover its velocity, the pressure, and other flow parameters. Basically, the aim of the study was to determine if we are installing multiple turbines in a row, uh, if we are installing multiple turbines in a row, after how much distance we should install the second turbine. So with this simulation, what we were aimed to do is to determine the lateral distance after the turbine, from which the flow will recover its parameters and its velocity. Okay, this is the flow domain again. So what the most important part after the modeling, after the CAD modeling of the turbine, was the meshing of the turbine, and we was supposed to capture a high fidelity solution and better result. For that, what we did is we meshed the whole flow domain. Different section of the turbine were of different thickness and different have different geometrical properties. So we have to mesh each individual section of the turbine with as much accuracy as possible. So basically, this picture shows the mesh model of a turbine, and we can see that various curves and various edges have different mesh sizes to capture the geometry accurately. So once we captured, this is a close-up view of the propeller and the debris protector. The debris protector is in orange and the propeller is in pink color. So once our complete, this is the mesh model of a turbine again, and it can be seen that all the propeller, the debris protector, rod, each and every has been meshed properly. So after generating the surface mesh of the turbine, and we were showed that that each and every part of the turbine has been meshed properly. So what we did is we generate a volume mesh from this surface mesh. So first we generate the surface mesh of the turbine, then the whole fluid domain, was volumetrically meshed. Okay. So basically, we used tetrahedral elements for 3D elements, and in 2D they were all tri elements. Okay. These are the solver settings which we use. We basically use ANSYS Fluent to model the flow through this turbine, and we use pressure-based solver and the steady-state solver. With obviously, we model the turbulence effect which occurred during the flow through the turbine, and then we actually model the turbine as it is made up of aluminum, because we were not taking into account the structural deformations in the turbine. We were actually just focusing on the fluid flow through the turbine. So it doesn't matter whether we assign an aluminum or any other material to this turbine. And we model the viscous and turbulent effects of the fluid, and then we use different solution methods and schemes to make sure that the solution is as reliable and as close to the real life as it is. And these were different boundary conditions we use. So what we did is we modeled three different types of debris protectors, and we installed one and then determine the flow properties. Then we install the other and then determine the flow properties. So different CAD models were made and different WC protectors were used. So finally, what we concluded was, whenever the flow passes through the turbine, the inlet flow velocity was 2.1 meter per second, but because of the diffuser installed on the turbine, when the flow reaches the propeller of the turbine, the flow velocity increases, and in different cases, different flow velocities were achieved. So, okay, different flow velocities were achieved. So, in case one, which is shown here, in which we install a debris protector with a blunt face with a wire gauze, and in case two, we install a debris protector without the wire gauze, and in case 3 we install a debris protector with a sharp pointed tip instead of a blunt tip. So we should remember that case 1 is the debris protector with a blunt tip and a wire gauze. Case 2 is without the wire gauze, and case 3 is with a pointed nose. So for case 1, we were able to achieve a maximum velocity on the propeller, maximum velocity of the water. As the water enters the diffuser section, the water velocity increases. So the maximum velocity achieved on the propeller section was 4.11 meter. In case 2, it was 4.22 meter, 4.23 meter. In case 3, it was 4.05 meter. And in case 4, the case 4 was without any debris protector. In case, actually, we removed the debris protector, which is not actually possible, but for simulations, we actually remove the debris protector. So the maximum velocity achieved at the turbine propeller of the turbine was 4.48 meters per second. And in different cases, different normal and axial forces were acting on the turbine, and we actually evaluated these forces. The negative sign in the normal forces shows the direction, because uh, it is opposite to the axis we defined in a positive direction for this whole simulation. So we calculated the normal and axial forces which will act on the turbine. So after evaluating all these values, these are the few of the results. Basically, this graph shows the velocity contours of the
Excuse
turbine, and it
me,
shows that.
uh, Mr. Asim, can may I interrupt a little bit? We are lacking behind a schedule, so I would request
Sure.
you please to swiftly go on with your presentation and maybe give us some recommendations at the end or whatever your final results were. Thank you,
Okay,
sir.
thank you. So basically, this picture shows some of the simulation studies and some of the results by which we were able to evaluate the maximum velocity that which will achieve at the propeller, and different pressure variations for different cases. And obviously, without any debris protector, the velocity, the increase in the velocity through the diffusers was maximum, and we can conclude that we can generate the maximum electricity as the flow velocity is maximum, because the drag is minimum in this particular case. So then analyze few of the installation schemes which were actually recommended by the manufacturer, and different installation options, and we actually concluded that throughout the length of the Ghazi Canal, catering for the effect of the drag which the turbine causes, we can install 20 to 21 turbines and 14 to 16 possible turbines in Upper Jhelum Canal and 20 to 21 turbines in Ghazi Canal, and this with minimizing the interference of one turbine on another in a longitudinal direction. And through our simulations, we were able to determine that a minimum distance of 20 meter is required laterally between the turbines, as the flow recovers its velocity 18 meters, 17 to 18 meters after the turbine. So if we install a turbine less than a 20-meter distance from a first turbine, the performance of the turbine will not be accurate. But if we reduce the distance, if we increase the distance to 20-meter or more than 20-meter between two successive rows of the turbine, we can achieve the maximum performance from s- multiple turbines. So this is basically the section of the Ghazi Canal passing through the Kamra where we plan to install the turbine because of security reasons. Okay, thank you. Any questions, please?
Thank you very much, Mr. Asim Shahzad, for your very informative presentation on more of technical aspect of the turbines. And I'm very sorry, but we could not. We are a bit short of our scheduled time, and our next presenter is already online. So I would quickly go on with the brief of what Asim Shahzad already said during his presentation. He mentioned something about the challenges and the risk related to this technology. He mentioned about the CAD modeling, where he has produced a meshing model of the turbine along with its other parts. Then he mentioned something about the pressure and the velocity profiles of turbine blades. Then he mentioned about the debris protector. He has already modeled his in its software. Then he mentioned something about the turbine park with overhead cables and gave something of a 20-meter of minimum distance between the turbine rows for reducing the wake effects of one turbine to the other. So I thank you very much, Mr. Asim Shahzad, for your nice presentation. We have some questions definitely for you from the participants, but due to some shortage of time, we are going to go to the next presenter, and we would see it out if we have some time after the presentation to address your questions too. Otherwise, what we would do is we would shift the question answers to today's end of the knowledge sharing session, where we would address the remaining questions, and if possible, we would ask your support in replying to those questions on the live session, or maybe later on through email to you, and we will relevant professionals or experts would be sent the questions. So thank you very much, Asim Shahzad, again. Thanks a lot.
Thank you, Jawad sir. Thank you.
So, ladies and gentlemen, this was Mr. Asim Shahzad on the side of the simulation studies for the installation of multiple turbines. A very well-informed presentation. Unfortunately, due to some technical issues, we didn't have enough time to carry on with his full presentation, but definitely his presentation would be available at our website. If anyone is interested, he can go and watch the presentation later on. And if he's interested in anything specifically, we can address those questions directly to Mr. Asim Shahzad later. So thank you very much again. And let's go on with our main schedule. We have our next presenter available with us. The topic of the presentation is design concepts of hydrokinetic turbines and performance in variable flows. I would really appreciate, and at front I'm very grateful to Mr. Tommaso Morbiato for agreeing to participate in our this SARC webinar. I'm really grateful that he showed this enthusiasm and agreed to support SARC Energy Center in its webinar. And Mr. Tommaso is a very busy man, so I would quickly introduce him and then give the mic to him. Mr. Tommaso Morbiato is a founder, CEO, and R&D head of Wind City company. He has a master's in civil engineering with a thesis on aeroelasticity of structures in 2002. He did his PhD in structural mechanics in 2008. He is active as a head engineer, R&D lead, and scientific coordinator of wind energy projects. He has also served as adjunct professor in industrial design and architecture faculties, and he chairs a European cooperation in science and technology action group. Thanks to his new energy conversion concept in variable flows, he was recently awarded the National International Prizes, which is a Startup Europe Award from European Commission, Edison Pulse from Energy de France Group, Progetto Marzato Unicredit Start Lab ABB Ability. So I'm very grateful again to Mr. Tommaso Morbiato for his agreeing to participate as a presenter. So I'm over to giving over to Mr. Morbiato for his presentation. Thank you very much, sir. And you are online now. Please go ahead with your presentation, sir.
So thank you, Mr. Hassan Javed, for giving me the opportunity to participate to this webinar. So we will start ahead now with the presentation. The topic, as introduced,
Um,
is
may
yes.
I interrupt, Mr. Morbiato? Your slides are not visible to us. So could you share the screen, your presentation slides, please?
Yes.
Your voice is very audible, very clear. Everything is okay. Yes,
Can you see
perfect, sir.
the
Perfect,
perfect, sir?
perfect,
Okay.
sir. Go ahead, sir.
So let's go on with our topic today for the presentation: design concepts of hydrokinetic turbines with an emphasis on performance in variable flows. As Mr. Hassan said, I will speak from the side of the company which I am R&D head and CEO, which is Wind City, where our concept was resulted a winner in European Startup Award and has the Seal of Excellence from the European Commission, right in the concept of transferring the technology from our small wind turbine system to a possible technology transfer into a water turbine system, an hydrokinetic one. So let's just briefly analyze the conventional and non-conventional design in hydropower. So hydropower, conventionally speaking, every one of us know that we begin from natural resources with potential energy, and we need some infrastructure in conventional hydropower to achieve pressure, energy, and kinetic energy. And then we go into the standard converter efficiency with more infrastructure. I put this sign here, just a funny sign of a house, meaning we need an infrastructure to do that. While in more recently, on the right side of the slide, with non-conventional hydropower, again starting either from kinetic energy in natural reserves with some potential energy in case of wave converters. The practical, so the engineering world, I find three cases ahead. So encased water flow, different power takeoffs, and open flow choice. So which one of these three lines to approach is all about non-conventional hydropower. In case of encased flow, we have to face still infrastructures and the energy conversion projects, and we had historically low efficiency designs, and now more advanced devices with Kaplan turbines inside, or also a French concept converting hydro power to air pressure. Then in the middle column of non-conventional side, we have a complete variety of power takeoffs from point absorbers, energy attenuator from waves, oscillating surge or oscillating column, water column. Always here we have to face with waves, so we are in open, let's see, in sea, ocean rather than canals, but here technology does not require infrastructure anymore. And the third option is the option open flow. Every one of us know that in this case we have a first limitation from the Betz limit, so we only have an amount of energy of 0.6 that we can convert. And in this case, we're talking about hydrokinetic, and what is important that in this case we can apply wind tech transfer, so having the same efficiencies of the wind energy converters, so reaching about an 80% of the BATS limit as a maximum efficiency. So just going briefly into the concept, we see the encased flow concept. This is that you can see here is a Singapore concept for a advanced wave energy converter. You can see there is a Kaplan turbine inside the concept. So this is an advanced wave energy converter concept. This is just what you can find from the Haas concept. This is a French concept and is about encasing water flow and converting its energy into a air pressure circuit, so extracting energy basically from a pneumatic concept, from a conversion from a wave energy concept. And here you can see just summarized the two most important power takeoffs in wave concepts. On the left side, you can see a more standard one, which has to do with a linear generator, a linear electrical generator, with a point oscillator concept. And on the right side instead, you can see a Swedish concept, a very recent concept with a very complex pneumo-mechanical drivetrain. And so you can see how much these concepts have to do with complex mechanics that many times has to do with difficult operations and increasing capex to achieve the effective power conversion. In the third case, we have the open flow concepts, which is right where our presentation will go deeply ahead from now. And mainly you have the two concepts of axial rotor on the left side and cross-axis rotor on the right side. Of course, when we have to do with hydrokinetic energy, the more we go deep from the surface, the more chance we have to have a higher water speed, especially in case of seabed and coastal areas. But what this slide wants to summarize from the point of view of design concepts is that also from this triangle that you see on the left here, water pressures of course linearly increase with water depth. And so what, for instance, the most important Scottish project is facing up to now, an open flow axial rotor concept in Scotland. I was saying that now they are designing at about 30 meters from the surface. Just imagine that you have to face, so with 10 kilonewtons per cubic meter times 10 or 30, sorry, times 30 meter of depth, you have to face with a 300 kilonewton per square meter pressure on the blades, just about considering the hydrostatic pressure. So this, of course, increases the overall self-weight of the structures and increase the overall inertia of the system. And what comes out is that if you increase the inertia of the system, then you need, as the cyclic scheme I show here in the left, the more you increase the inertia of the system, the more you need a higher cut-in speed from the water to achieve your energy conversion rate. And so this is a like a cyclic process that allows you with or even more inertia of the system, because now you're going even more in depth, and in this cycle is not really given that you will achieve an optimal design. So this is why always in hydrokinetic design it's better to understand that the optimal point of design would be rather a trade-off between a smaller turbine, a buoyant perhaps concept, and a lighter design, a small inertia design, perhaps in modules, more modules that will allow you to keep the overall design in a optimal cost, in an optimal material consumption range. And so talking about buoyant concepts, hydrokinetic turbines, these are the most conventional design that we found for canals, or also for coastal areas in oceans and seas. You can see here in the upper part 2 axial rotor concepts, and in the lower part you can see a cross-axis rotor, which is even though its rotating axis is horizontal one, still this is a cross-axis rotor, because it becomes clear that the generator, the permanent magnet generator, lies on the central line, and that the blades rotate in a sense that is cross-axis oriented with the water flow. So where our design and our challenge now in the tech transfer from our wind turbine concept is that we all realized that when we go to the most standard business case, where we went through, for instance, with port authorities in Italy or in Croatia or in France, and we are all speaking of possible application in variable water flows. Variable water flows, we realize that pretty much all around our cities, because they can be found in navigation-induced surface flows, or in river mouth flows, or in tidal periodic flows, or also in seaside, landside breezes that also induce surface flows in the water with a circadian rhythm. And pretty much from what we can see in the water flow measurements, for instance, in Port of Venice, these four water flows are pretty much mixed up together. So the problem is with space variable flows, and first understanding in design is that due to its high power coefficient, and due to the fact that it's omnidirectional in behavior, the Darius wind turbine concept has been adapted for water in most cases. Still, conventional fixed pitch Darius turbines suffer from two drawbacks: low starting torque and shaking due to cyclical variation in blade angle of attack. And these points can be overcome, for instance, by using helical blades instead of straight blades. But still, we have not large starting torque. So, also considering that flows are not only space varying, but also time varying. For instance, you can see here in the upper figure that in 1 hour you have oscillation also from 1 to 2.5 meter per second, or also you have variable flows induced by ship. And in all these cases, you have time varying flow. So you can understand that the standard machines, so standard design, they are designed for a regular flow that allows startup, production for a half an hour, for instance, and then perhaps another half an hour of production with only two, or let's say just 10, 12 per day startup and shut off cycles. But in variable flows, every 5 minutes you have, or every 10 minutes you have one cycle. So can you imagine all the starting time and shutting down time? So very much of the time is spent in transient mode, and production with standard designs is very low. And this is due to the fact that, as you can see from this picture, if you consider the pitch of the blades in standard position for the radius, so for the cross-axis turbines, you have a power coefficient which is high only at higher tip speed ratio, so it's high only when the turbine is started. But in the startup region, so with the red bold curve, you have negative or zero power coefficient, and you need a variable pitch, for instance, of 30 degrees on the blade axis to achieve in the red dotted curve to achieve a sufficient torque to start the turbine. But in this case, you can start the turbine and then you have completely not satisfactory behavior and at standard velocities. So you achieve self-starting and then you cannot produce with a high power coefficient at optimal tip speed ratio. So what you can do, there are some variable pitch concepts, like in this case, where you can achieve, as you can see, a better performing startup region with higher power coefficients. And to achieve this, you need complex radial arms, you need control arms, you need to implement, which is not really something standard or something that is commercially ready, that is market ready. You need to have a variable pitch concept on the blades. Also, very important is the fact that there is a moment of inertia dependence in pulsating flows. So, as you can see in the left, this is something that is a Japanese research. If you consider a sufficiently pulsating flow, for instance, in 30 seconds to 1 minute, you have the fact that you have an increase in efficiency if you have a lower inertia. So can you imagine, as we are doing in our patent concept, if you not only consider an inertia range, but you consider that you can have a variable inertia in your turbine. So you can see that with the oscillation of water speed, if you have a small turbine, you have a rapid turbine. If you have a big turbine, you have a slow behavior turbine. So if you can combine the two of them, you can achieve at the same free run speed for any oscillation of the water speed. And so this is our concept for wind, for small wind, that we're trying now to adapt to water flows. And we have achieved for the first time with our patent the first passive, fully integrated pitch and inertia variable geometry turbine. So we do not have a family of turbines for a family of power curves. We have only one turbine that can have all the power curves inside one turbine. So we can envelop all the power curves to achieve in any variable water flow always the best torque, so the best power curve. So this is just an impression from our website of the concept where we are working on. We're working on a floating and balancing buoy, electrical generator in the not submerged part, mechanical shaft going down water, and our turbine, which we are just transferring from wind, is 2 kilowatts, and in water is 25 kilowatts, 4.5 square meter concept with variable geometry radial arm. Of course, it has all the good advantage that you mentioned in your webinar for the hydrokinetic turbines. So it's low speed, it's reversible, compliant with real flow, and reliable in tidal and current, and it self-starts also in water. So just to summarize about the design, in hydrokinetic turbines, we always need to consider that efficiency and efficacy can be at two complete different sides of an axis, and they have to do, of course, with infrastructure and high capex from one side, and no infrastructure and reversible concept in the other side. So we are trying, of course, to go, not only us, but everyone in hydrokinetic design need to go in the upper right region of the Cartesian diagram, and we really need to not go in the left side and the downside, having constraint from wave or regular flows or active controls. So just to give you a last impression about concerns. Of course, we need to understand that marine concerns with biofouling is one of the greatest challenge that we need to face. Just remember that biofouling is responsible for fuel consumption increase up to 45 to 50% to maintain cruise speed in any type of ship. And so the same is for our hydrokinetic turbines. And about canals, at least in Europe, we need to have very much in mind that river management after hydrokinetics turbine positioning need to consider energy balance of the system, a design speed decrease in the canal, so tangential stress perturbation at shores, and ultimately embankment durability. And this is our team. I am Tommaso Morbiato, and this is just the relations that we are trying to build to develop our turbine concept. And this is us with our contacts that you are very welcome to use to get in touch and try to cooperate for this challenge. Thank you very much.
Thank you very much, Mr. Tommaso Morbiato, for a very well-informed and detailed presentation on the design performance of this variable flow turbine. So I would briefly just overview what Mr. Morbiato said in his presentation. He mentioned in the start about the axial rotors and the pressure difference in rotor due to the depth of water. Then he mentioned something about the variable flows due to tides, river mouths, landside breeze, and seaside induced effects. Then he mentioned some drawbacks of the conventional fixed Darius turbines. He also mentioned something about the time variable flows, which is between 1 to 2.5 meter per second. He mentioned something about the various cycles of speed in variable flows compared to the regular flows. He mentioned about the pitch degrees for varying speed of the turbines, high pitch degrees for lower speed of flows, and on the opposite, if there's a low pitch degree, then you have it is for the high speed of flows. Then he mentioned something about the inertia dependence in pulsating flows, the integrated pitch and inertia variable geometry turbine concept developed by him. And lastly, he gave a graph on which he mentioned that the design turbine should have a higher efficiency with rather no infrastructure for installations which would serve the purpose. So, Mr. Morbiato, thank you very much for your presentation. We would quickly jump to our question answer session. We have one or two questions. We are lagging behind on the schedule, so we would like you to reply to those questions. We have a question from Dr. Shoaib Ahmed. He has asked a question that can your research on blade design can be useful on small scale and low cost submersible turbines, please?
Yes, thank you for the question. Yes, the answer is yes. All our R&D research is going in the sense of keeping down costs. So our submerged turbine as the challenge and the objective to keep levelized cost of electricity as low as possible. And currently we are designing it to be in the average LCOE of the fuel mix and of conventional wind energy. So of course, what we're doing is we're trying to keep down the production cost, which is very much easy for us coming from the small wind sector, because we already are trying to commercializing small wind turbines at a cost that is on average with the small wind sector, which is slightly high than the standard wind energy. But as we have a 10 or 8 time scale factor due to the fact that, of course, water speed and water density is giving much more energy than air density. So we're pretty much staying in the standard selling cost for instance, photovoltaic projects or big wind energy projects. Thank you.
Thank you very much, Morbiato. We have a connecting question related to this reply. One of the participants has asked that what about the complexity of the mechanical design for your turbine? It looks very complex. So could you just briefly touch on that aspect?
Oh yes.
From the perspective of our webinar, we are talking about very simplistic type of a technology which can be implemented very easily indigenously by local South Asian countries. So in perspective of what do you see about it?
Yes. So I was mentioning this concept here, saying that the variable pitch concept can be very complex. This is an Australian concept that you see here, and this effectively is complex. Conversely, in our case, this case, all the variation is kept inside the radial arm, so, and is passive. There is no active control. So this is a very easy concept, and this is why we are able to stay with the costs in the average renewable energy cost of any renewable source. So with no extra costs, it's just a natural balance of dynamical equilibrium between centrifugal force and fluidodynamic forces and fluidodynamic pitching moment. Okay, so there is completely no electronics underwater, and is all self-balancing, and any mechanics which is just about spring group, okay, is just inside a watertight radial arm. So really it's just a very easy concept, and we are very keen to proceed in this TRL because we can see that we will be able to deliver for the first time an easy technological concept, so reliable technological concept to the world of the variable water flows. Thank you.
Thank you, Mr. Morbiato. We have a last question from one of the participants. The question is related, is your turbine's rotors good for unidirectional running water? If so, what is the generally speed range of that?
Yes.
We are talking in the perspective of canals. For example, in Pakistan, we have a canal with wind speed with water speeds of 1.2 meter per second. So, how do you see that one?
Yes, yes. We are finalizing our design in order to have startup behavior above 0.7 meter per second, 0.65 meter per second, and so this is fitting. And the about the use in unidirectional canals, this is also one important thing to consider. This is an omnidirectional turbine concept, which means that can be implemented in any direction water flows, and this implies that it also can be used in unidirectional water flows. So the wide the number of applications of this turbine concept is very wide, and our floating and balancing buoy concept is ensuring that the turbine stands always in vertical position, and we are also developing a mooring concept, with just mooring concept of 3 ties fixed point that will allow it to be fixed at the shores of any canal. Of course, also in modules, the more modules will be on the canal, the more easy would be to achieve the standard mooring concept. Definitely this can be done, also because our first demonstrator that we are planning and organizing in the first quarter 2018 will be in Lake Garda in Italy, northern Italy, Lake Garda, at the mouth of a hydropower electricity canal going into the lake. So to answer your question, our first demonstrator will be right in a canal position. So it definitely is possible to use in canals. Thank you.
Thank you very much, Mr. Morbiato, for a very detailed reply. And I must admit that we are quite impressed with the level of presentation which you have just delivered. It was wonderful to listen to you. We all benefit a lot from your detailed presentation. And we would have liked to ask you more questions, but due to shortage of time, we have to close the session now for a short break.
Sure.
If you are willing, you can attend our after the break. We can have a session on the knowledge sharing where we have a lot more questions from the participants. So if you are able to participate, I know that you are a very busy man. So if possible, you can attend that session. So thank you very much again for agreeing to participate in our webinar.
If I cannot be there, then please write me emails and let's keep in touch. It was very a pleasure for me to participate in this webinar. Thank you for inviting me.
Thank you very much, sir. We would definitely send you the questions if asked by the participant. And moreover, we would like to collaborate with your organization more in the future for our future projects or programs.
For me as well. For me as well. Thank you very much.
Thanks a lot, sir. Thanks a lot.
Thank you.
So, ladies and gentlemen, this is the end of our session before the break. We are quite late as per our schedule. So, instead of 11:30, we would like to get back at 11:35, maybe 5 minutes delay. And we have two more presentations along with a knowledge sharing session and a concluding session of this webinar. You are most welcome to write any questions at any time of the webinar. Thank you very much and see you later at 11:35. Good morning, everybody, and welcome back to SARC Energy Center's webinar on use of submersible hydrokinetic submersible turbines. We before the break we had excellent presentations from Dr. Nawaz Akhtar on the planning of installation of a hydrokinetic submersible turbine. We also had a short interview of Mr. Trey Taylor, Verdant, USA, on the commercial aspects of hydrokinetic turbines. Then we had Mr. Asim Shehzad from Institute of Space Technology on the simulation studies for the installation of multiple turbines. And at the last, we had an expert from outside the region from Italy, Mr. Tommaso Morbiato, who gave an excellent presentation on the design concepts and the performance of his patented variable flow turbine being developed by him. So now we move on to our next session. We have two basic presentations in this session. So the first presentation is from Mr. Malik Nadeem Awan, who was basically an entrepreneur working for development of this technology in Pakistan. And he would give a business perspective of hydrokinetic submersible turbines in Pakistan. We thought that apart from the technical and the policy side, we should have some perspective from the business community. And he being an excellent entrepreneur for promotion of this technology. So I would quickly introduce Mr. Malik Nadeem Awan to you. Mr. Malik Nadeem Awan is basically went to Germany in 1991 and went to a vocational school and got diploma Außen Handels in 1994. Then he started an Awan Yandalux Pakistan Private Limited company in 2006 for solar systems in Pakistan with cooperation and partnership of Yandalux GmbH Hamburg. He and his partner Mr. Dor met with Dr. Komsi, which gave an earlier presentation yesterday in Hamburg in end of 2010, and they agreed to purchase the first turbine for Pakistan. So he presented his business model to Chief Minister of the Punjab province of Pakistan. This presented his business model to him back in Berlin in 2011. With his efforts, he signed an agreement with Pakistan Air Force to install this turbine in Ghazi Barota Canal in Pakistan. And with the collective efforts of government officials and Pakistan Air Force and the efforts of Institute of Space Technology, Islamabad, specifically Mr. Asim Shehzad, and with the support of Mr. Nawaz Akhtar from SARC Energy Center, they started a pilot project at the Upper Jhelum Canal, installed that turbine in the Jhelum Canal, and they evaluated the results out of that canal, and based on which we are conducting this webinar study. So Mr. Malik Nadeem, we are very grateful to you for agreeing to participate in our webinar, and we would really request you to give the business perspective of hydrokinetic submersible turbines. And for that, I hand over the mic to Mr. Nadeem Awan now. So, Mr. Nadeem Awan Sahib, am I audible to you?
Okay. Hello. Assalamu alaikum.
Walaikum assalam, Nadeem Sahib. Your presentation is very visible, very quite clear. You can just turn it to full mode page, maybe, and then your audio is also very clear.
Okay. Thank you. I love you. Bismillah ar-Rahman ar-Rahim. I am very thankful for SARC Energy Center that they have provided me opportunity to present my business concept and my personal views regarding to run of the river submersible turbines in Pakistan. So as I have present my short introduction, as we started small hydropower in Pakistan 2011 with Pakistan Air Force, and then we have studied Pakistan canals and rivers. So we come from energy situation and alternative sources. and we think that small hydro turbine is the best option for Pakistan in that time. And Pakistan Air Force suggested us to install a smart hydro turbine in Ghazi Barotha Canal. In that background, we started in Pakistan this concept, and but later on we have studied that we need a proper study on water resources, uh, energy prices, uh, the problems of river environmental issues, and similarly the approvals of governments. So we start with these points with uh, a proper study. So we come to next with Institute of Space Technologies, and we join them for these studies. And finally, we submitted uh, the data from Pakistan energy situation, require a total requirement, production capacity, average production, household, industrial, agriculture, commercial, governmental, and street lights, and so on. This data is now available. Now the need of explore alternate energy sources is because energy crisis is one of the major issue of developing nations like Pakistan. The growing population and the industries of our country require electricity more than ever before. Due to financial limitations, the power production utilizing liquid or gaseous fuel is becoming a heavy burden onto the budget. Therefore, alternative energy sources need to be harvested for the national's good. So, measures to meet shortfall: energy conservation, energy management, production capacity enhancement, thermal, environment issues, increasing prices and security of fuel, nuclear, and then hydro. Alternative energy sources preferred is renewable energy sources available naturally: solar, wind, hydro energy acquisition options, potential energy, kinetic energy, and we come to present small hydro turbine in form of kinetic energy. So I present my turbine in physically. It weighted just 300 kilo. Its height is only 3.5 meter, and it can hang, install very easily on Pakistani rivers. Then working principle is it is just need velocity of water and then depth of water. There are two main points to install this turbine. We have proposed in Pakistan is the one of the best country in the world for canal channelization and length of canals ever in the world. So we have proposed a turbine park in which 12 hydro turbines has been installed in serial at a distance of 8 meter to each other after the creation of an overhead structure. The canal's surface width is 94 meters, but owing to Jeanette in the side walls and to install the turbine 1.8-meter depth into the water. The canal width is intentionally been chosen to be 85 meter. So proposed turbine park, each turbine is around about 2.5 meter, and the next park will be 50 meter with the distance. Then so one unit produce 5 kilowatt, one park probably 10 to 12 turbines produce 50 to 60 kilowatt, one park serial and parallel 20 to 24 turbines 100 to 120 kilowatt, and multiple parks 100 to 120 turbines 500 to 600 kilowatt. So this is a satellite view of Ghazi Brotha Canal, and especially Pakistan airbase camera view. It will be 5.5 kilometer, and total turbines
Uh, I think we have lost connection with Mr. Nadeem Awan Saib. So, if are you listening to me, Mr. Nadeem Saab? Can you write me some text message? Is it some kind of an audio problem or internet connection problem? So, ladies and gentlemen, let's check out if Mr. Nadeem Awan is going to reconnect with us very shortly. I think. In the meanwhile, we will try to make this session more interactive by asking one of the questions being asked by the participant. In the meanwhile, with me, I have with me Dr. Shoaib Ahmed, and we have a question that from the participant, that what will be the use of this modeling techniques which were earlier mentioned by Mr. Asim Shehzad for advancement of this technology. Those I think the participant would like to know that with this 3D analysis on CAD and these things, and with us being saying that the technology is very simplicity in its installation. So, what's your opinion on this one, Dr. Saab?
Well, thank you, Asen. Uh, yes, I agree that technology is very simple, and we would like to keep its applications very simple. But at the same time, the work done by Mr. Shahzad is extremely important for the advancement of this technology itself. I've just viewed his presentation, the part of this presentation. He's carrying out modeling on it. So I suppose this modeling can be very, very helpful for improvement, bringing improvement in the existing designs or designing the new types of the turbines. Especially as he was mentioning that just by improving the cone of the debris protector, he was able to increase the water which was touching the turbine blades. Likewise, same modeling can be helpful for improving the design of the diffuser. Similarly, similar modeling can be helpful in improving the designs or improving the efficiency of the blades. Similarly, these type of modelings can also be useful for determining the wake effects, the effects of the turbulence on the blades, and the efficiency of the turbines, and determining the distance, I mean side by side distance between two turbines, what is the optimum distance. Similarly, determining the distance between the optimum distance between the cascade configuration as well. So I appreciate the work which they have done, and this is going to be very, very useful in my point of view. Thank you.
Thank you very much, Dr. Shoaib Saab, for your very detailed reply to the specific question. We are really blessed to have him with us in this South Energy Center. With his experience, he contributes a lot during the research projects and specific studies. So, over to Nadeem Saab, if he is still with us online. Nadeem Saab, can you hear us? I think there is some issue with Nadeem Awan Sahib's microphone. Nadeem Sahib, we are online asking questions. So if you can, in the middle, in the meanwhile, just try to reconnect with us. Your microphone seems to be not working, but your presentation we can see it is working. So you please carry on your this troubleshooting with the microphone. So in the meanwhile, I will shoot out another question to Dr. Shoaib Saab. So Dr. Saab, we have talked a lot about the design and the application of this technology, but just out of curiosity, I have this question came to my mind that what do you think would be the operation and maintenance of these turbines? Like these specific experts are telling us about installation of 1000 and 2000 units of these small turbines in the canals. So how do you see we would pursue with the in future the operation maintenance of a single turbine or a row of turbine? Would we have to stop the river flow of the river to repair them or something like that? Just a naive kind of question. Over to you, sir.
All right, thank you, Yasin. That's a very practical question, and of course, whatever reply I have, that's based on my experience. And let me admit that my experience on the real application of these turbines is very less. Okay, but however, what I could foresee that types of maintenance requirements is, um, I think the majority of the maintenance would be the scheduled maintenance. I say so because realizing the nature and the simplicity and the ruggedness of the technology and the matureness of the technologies in present time, I think there would be very less breakdowns. And in these, the breakdowns, majority the maintenance requirement for unscheduled maintenance would be on the electrical side rather than the turbine itself. However, the scheduled maintenance of the turbines um, should be it should be one of the requirements, though it should be very less compared to, let's say, windmills or others, but there is a requirement. The foremost requirement would be the removal of the debris on those things which during the operation gets clinged onto the blades or the body of the turbines. So that should be one of the very I think most maintenance resources would be going to that direction. Should be that I mean that should be taken care of, because knowing that in the SARC the canals and the rivers, they are not as clean as one should think about them. So that would be one of the requirements. Other scheduled maintenance, whatever the manufacturer tells you, especially from seals point of view, they should not leak. And from the external effects of the corrosion or the water or the sediments on outside of the turbine and its body, probably maybe in years, after 3, 4, 5 years, there is a need to repaint or place new layer of protective paintings or material, whatever. Uh, that type of, I could foresee these types of problems. But generally, they will remain low. They will remain low. In the again, why once again I would summarize that electrical side is more prone to for the maintenance, and turbine and whatever is inside water should, in my experience, based on my experience, should be less prone to the unscheduled maintenance. Thank you.
Thank you very much, Dr. Saab. I think you very rightly summarized the whole issue surrounding the operation maintenance of this specific technology. And this is, to us, we are still in the learning phase, and to us, this is a very novel and the new technology. And to my understanding, the operation maintenance for this technology would not be on the same scale as to the other dam projects or the run of river projects. So thank you very much again for your very detailed reply. We are trying, ladies and gentlemen, we are trying to reconnect with Mr. Nadeem Awan for his leftover presentation. In the meanwhile, since he is having trouble in connecting with us, so I would like to move on to our next session. We have with us Dr. Irfan Yusuf for his presentation. If we can see it out. If we find that Mr. Nadeem Awan is able to reconnect with us later, we will allow him some time after Mr. Irfan Yusuf's presentation. So let's try a last time. Mr. Nadeem Awan, can you listen to my voice, sir? Well, I don't think so. There's some issue at all. So, ladies and gentlemen, once again, if you need to ask any questions, if you need to reply to anything, you can write it back to us. Moreover, I should emphasize the need for your comments, specifically your recommendations, which would serve huge purpose for the development of this technology in future. You can write us right now your recommendation, or later you can write us via email any recommendation, any specific guidelines or ideas you think which would serve the purpose of increased deployment of this technology in South Asia member states in future. So let me go on to Mr. Irfan Yusuf. Mr. Irfan Yusuf is basically a director of policy and CDM NAMA's environment side in Alternative Energy Development Board, Pakistan. Alternative Energy Development Board Pakistan is basically the federal agency responsible for promotion, development, and indigenous development of renewable energy products and projects in the country. So this organization has been working from 2005 up till now, and Mr. Irfan Yusuf has been working there for last, I think, no, maybe more than 14, 15 years. And Mr. Irfan Yusuf has held several positions in the organization. He has worked on several projects ranging from solar PV off-grid, solar on-grid projects. He has also worked a lot on wind energy projects. Then he was responsible for working on the international cooperation with donor agencies and project developers. He has also done his masters in renewable energy from the University of Engineering and Texla. Then later, recently, he has finished his PhD from the same university back in 2015. If 15. So Mr. Irfan Yusuf has had a huge amount of extensive experience on the policy side and the regulatory frameworks developed in Pakistan for the last 14, 15 years. I think he would contribute a lot in his presentation on what kind of policy measures need to be taken for increased deployment of this technology, and plus maybe some kind of incentives or anything like that. So let's, ladies and gentlemen, get on with Mr. Irfan Yusuf. He is available with us online. So I will hand over to Mr. Irfan Yusuf now. So Dr. Irfan Yusuf, sir, are you listening to my voice? Am I audible to you?
Yeah, very much audible to me. Thanks, Assalamu alaikum to all. Really grateful for providing me the opportunity to present, discuss.
Dr. Saab, can I pause you for a short minute? You need to, check out that there is a lot of echo coming from your microphone, and secondly, you need to increase the, what do you call it? The overall presentation view is very small, so you need to make it on the full page view.
Is it okay now?
Yes, it is okay now.
Voice is very shrill.
The voice is very shrill. Can you just hold the mic a little bit further so that your voice is a bit clear, because it's very shrill. Can you speak now?
Yeah, no, is it okay?
Oh, that's perfect, sir. Perfect. So I think the mic is yours. Please go ahead with it. Thank you.
Really thankful to SARC Energy Center for providing me opportunity to present during this webinar. Submersible turbines is really a new concept nowadays, and so far developments have been made in technology developments and different prospects of utilizing the available potential in the canals in different parts of the world. But still there are a lot of things that need to be done for promoting submersible turbines in a large way. To us, policy plays a very um, primary role in promoting such a kind of technologies and interventions, um, conducive policies and existence of a policy mechanism and road map for uh, deploying such technologies is very essential. In my presentation, I'll just run over about the policy mechanism that's available in Pakistan, the potentials of that can be harnessed for such kind of technologies, what are the current policy mechanism existing in the country, and what needs to be done. Because this is very essential, very important to note that what should we give to the end consumers or the deployers for adopting to this new technology concept. Giving you an overview of what is small hydropower potential in Pakistan. Basically, the country is blessed with five rivers that's running from upper Himalayas, and it goes down up to the Arabian Sea. It comprises of number of tributaries, and it has a large canal system that's spread over all of the country for agriculture purposes. Um, Technologies like this submersible hydro turbines have a large deployment potential for in areas where the tributaries and canals exist. This is the primary area where actually the most of the large hydropower plants are being planned in the country. From there, a network of canal tributaries and the other hydro structures uh, emerged for different purposes, including drinking water and agriculture. The second circle indicates the area where major deployment of canals in Pakistan exists. That provides for cultivation of crops in different parts of the country. Talking about the available potential and ranges of the small hydropower, what we can see from the table that the KP, Punjab, Baltistan, Sindh, and Azad Jammu and Kashmir, all the five segments of the country are well blessed with the small hydropower potential, ranging from zero point 0.2 megawatt to 40 megawatts. This also includes number of sites that are located at small waterfalls, natural waterfalls, canals. Uh, then these canals are best suited for deployment of submersible hydro turbines for generation of electricity. As I indicated, policy mechanism is very essential for the deployment of such kind of technologies. Just providing you an overview what the policy mechanism are exist in the country. Our policy has mandated ADB to facilitate small hydropower sector investment in up to 50 megawatt. That means micro, mini, high, and small hydropower plants starting from kilowatts to 50 megawatt come up within the purview of this policy that's been administered by AEDB. These projects basically are allowed to be undertaken under different modes that include solicited and unsolicited. Since in Canal Falls, unsolicited modes are being deployed because a solicitation has not been done in the country for such interventions, and more realistically, the submersible turbines will be installed. These going to be in unsolicited sites because of lesser data and lesser proximity of feasibility studies done by the public sector. Other policy, it also allows government guarantees mechanisms for small hydropower plants. These are primarily for large scale projects that are going to be connected to the grid for supply of electricity. However, there can be some mechanisms for distributed generation of electricity from some submersible turbines have been installed in different locations. We feel that there needs to be an incentive mechanism announced for the promotion of such kind of technologies. Uh, these incentives should be a mix of financial and fiscal incentives that would ease the investment scenarios. Um, um, as we go through the renewable energy policy mechanism, that's been evolved since 2006 and being implemented, that includes um, exemptions of duties and taxes, allowing income tax exemptions, repatriation of equity, PKR, USD parity, and return on equities and other kind of sovereign guarantees and mandatory purchase of electricity. These are a very conducive and important policy mechanism that need to be set in place before we can go forward for the promotion of such technologies. More importantly, things which is to be considered at the moment for evacuation of power is availability of grid for such kind of technology, because in most of the cases the sites available are usually off-sited, away from the national grids. There need to be an infrastructure available. The power purchases need to be there for evacuation and distribution of electricity. Upon the current developments, there have been different technologies have been deployed in Pakistan, likewise in other parts of the country, SAARC region, like in Nepal, Sri Lanka. In Pakistan, there have been utilization of Cosworth turbines, Pelton wheel turbines, and Kaplan type turbines. However, the submersible turbines have not been deployed to that level that should have been uh, consider that this technology can commercially be deployed for different applications, including distributed generation. Uh, Talking about the prospects, how good is the prospect for such kind of a technology intervention, and what need to be done for promotion of submersible hydro turbines? We can segment it these into two major interventions. One is on-grid large-scale hydropower projects. These projects can range from 1 megawatt to 10 or 20 megawatts, because in canal falls usually the ranges of available potential as per the resource available in Pakistan range between 1 to 20 megawatts. For that purpose, um, we can deploy the submersible turbines for within the regions where on grid availability can be ensured. The investors can be promoted for direct foreign investment, equity partnerships, debt financing, credit lines. This can be very prospective for small hydropower projects in the country. But the most important thing which need to be taken into consideration by the policy makers and the renewable energy policy specifically talks about providing security packages for small to mini interventions. That's about the country in profile for the energy supplies. More than 22 million electricity consumers are facing energy shortages in the country, and more than 70 million people are not connected to the grid. The networks of small tributaries, as indicated in previous slides, and the canal potential is available in the country can be utilized by deploying submersible turbines to electrify all those areas which are so far not being electrified or provided electricity services in the country. There can be a number of interventions that can lead towards uh, more promotion of the submersible turbine. That includes community scale micro mini small hydropower projects under different modes. One of the most prospective models that have been deployed in SAARC region, that includes energy services companies model. Under this model, the private sector companies can be encouraged to install these submersible turbines to generate electricity and distribute the electricity to the end consumers, and do the energy services. For that purpose, what private sector or the lenders or the governments can do. That includes grants and loan schemes, rental models, proactive use of small hydropower for economic uplift is very important component that can be integrated into these models. Likewise, if I would share the experience of our 100 Resport program in Chitra region, what they did, they installed more than 103 micro hydro turbines. They generated electricity and supplied to the Chitra region for not only for electricity, lighting purposes, but also for generating economic activities that improve the economic life and economic value of the country. This is very essential part as is interlinked with the electricity supply that lead towards economic uplift. There are four distinctive issues that have been faced so far that need to be taken care of. There can be a number of more, but to us, four major areas that need to be taken care of before we off take the such kind of technology interventions, so that we can get benefit of such kind of technological in developments in the world. Uh, First of all, there should be a clear policy mechanism with distinctive targets, risk metrics, clear assigned responsibilities, and supporting measures. This should be clearly identified, set in place, so that whosoever want to invest in these technologies and get benefit of the available potential should know what he or she has to do, to whom they have to contact, who will be the interface from the government side, what the government is intending to do, and how can they get benefit of available policy mechanism in the country, so that they can get hold of the potential and generate electricity for the different models that have been explained earlier. One window facility for is very essential for all kind of interventions, because in we feel that there should be one interface of the investor or the developer or the whoever is to run the technology. Otherwise, as we have been experiencing that there are a number of windows that a company or services entrepreneur has to face while undertaking the project, that basically enhances the project development period. This increases the project gestation period, and also creates so many risks that compel increasing of the project cost. These need to be taken care of by having only one window facility that take care of all the prospective issues that come across while executing or undertaking such kind of projects. The other important thing is that site-specific technical data should be made available, so that whosoever intends to do any kind of installation should know upfront where it is going to execute the project. Sorry, where it's going to execute the project, and what would be the prospective resource available in the at the particular site, how much an investor can generate, and how can it can disperse the electricity generated to within that proximity of the site available. The last important thing which we feel is that the site that's available for deployment, whose data is made available to the general public, should be within the proximity for grid or and or within the load center, so that the disbursement or distribution costs should be made minimal. Supporting mechanisms that are needed for deployment of such technology in a small hydropower development, that can include, there should be a set tariff mechanism for sale purchase of electricity, so that the energy services companies or the investors or the developers should know upfront that at what cost they are going to sell the electricity and make their profit as what they need or require. Uh, Also, it is essential for the community who is going to be connected to such kind of electricity generation facilities, so that they should know at what price they're going to purchase electricity from the facilities being deployed. The other important thing is that there should be a well-placed, well-established, well-set-in security documents, likewise implementation agreement, or any kind of a security package that the government of Pakistan intends to offer to energy services companies or developers or investors. The other important thing is there should be a nexus between federal and provincial governments. Um, as far as the Pakistan is concerned, the agriculture and irrigation sector is privatized. Oh, sorry, not privatized, but provincialized after the 18th Amendment. Since the intervention of the provincial governments uh, in a large way for such kind of technology innovation and deployment, there is a need that the federal and provincial governments or state governments should be in line with such kind of a development and have a good nexus so that the deployer of the technology should face um, the all the interventions in a very coordinated way. The other important thing is that market mechanism should be set in place for the energy services companies or the developers or the investors so that they can benefit out of those and can have a better overlook of how they can make profits and what interventions they can make. Buyers of electricity is very important for such kind of interventions. Um, if energy service company intends to generate electricity and to supply to the end consumers, uh, they need to be a real time guarantee or kind of a mechanism available before the investor that the buyers will remain intact with the seller, so that long term operations of the plants can be made possible. um, there should be certain areas that should be highlighted or disseminated before the energy services companies or the investors or developers where the distribution network may exist and where that can be used for distribution of electricity in in within the proximity of areas. And if there is no distribution network available within that region, what can be done is that a certain set of technical parameters should be set in place that should be made part of the overall scheme for generation and supplying of electricity within the proximity of that load center. The other important thing which going to support development and promotion of these kind of technologies is local manufacturing of the plants. As I have indicated in previous slides that there is a lot of potential available in the country and likewise in other parts of the SAC Energy Center. This kind of a potential can be deployed by these submersible turbines uh, and can be utilized for generation electricity. However, localization of manufacturing technology is very essential to reduce the overall cost. For that purpose, uh, what we can do is we can encourage transfer of technology. We can create direct investment partnerships, and there is a need to arrange debt financing and credit lines. For that purpose, we can engage with donors and the lenders so that a mechanism can be set in place for transfer of technology and manufacturing of such kind of turbines like submersible turbines. This is all this available with me. I'm all available for answering to any question related to my presentation or any additional question if that may arise by the audience in due course. Thanks.
Thank you very much, Dr. Irfan Yusuf, for a very detailed presentation on the policy aspect. And you very rightly mentioned that policy interventions like these are necessary for the uptake of technology. And for the consumption of all the participants, I would like to mention again that since this technology, submersible water turbine, is a very new and novel technology, so then what we did was we asked specifically from our government bodies that please give a presentation on the aspect of maybe micro hydropower project, because it is very closely related to the submersible water turbines. And since the policy interventions and regulatory framework required for the micro hydropower projects would be similarly are very close to the submersible water turbines, so this also gives you a perspective of how you would move forward if you would like submersible water turbines technologies to uptake in your specific relevant country. So I would quickly go through with what Irfan Yusuf Saab has already mentioned in his presentation, just to give a overview of that. He mentioned something about the small hydropower power potential in Pakistan, which ranges between 3,270 megawatts, huge potential in the northern areas of Pakistan. Then he mentioned about the close relationship required with the provisional government, because they are the main entities responsible for overtaking the projects or taking the electricity out of those projects. Then he mentioned specifically in RE policy 2006 of Pakistan, whose salient features include doing projects by Alternative Energy Development Board under 50 megawatt of installed capacity, with the private sector investment, and the incentives being offered by the government is in range of like for example, it gives an incentive such as 17 to 18 percent of return on equity in the tariff, which is a very lucrative kind of a offer by government of Pakistan. Then it also gives a upfront tariff for SHP projects regularly announced by NAPRA, which is the National Electric Power Regulatory Authority, the regulator for electricity in Pakistan. It also gives incentives such as it gives incentive that there's a mandatory purchase of power from the producer, and there's a binding for the utility to purchase the power from them. Then he mentioned something about we had earlier also talked about the same topic of community scale projects under energy services company model. He mentioned that since these hydropower projects have been micro hydropower projects have been working under this model, so the same could be maybe could be replicated in form of submersible water turbines. Then he mentioned some issues faced by the small hydropower project sector, which includes the technical data availability. That is very important, because for a project developer, the availability of free data access should be there, so that the developer should be able to work on developing those projects. Then he mentioned about the one window facility requirement for this sector to overtake, because in some instances, if 2 3 agencies are involved, so it becomes a problem for the project developer to go from one door to two door, second door, third door. So if it's a single entity which is responsible for doing all these licensing and approval, it's a very kind of a lucrative environment for the investor. Then he mentioned about the supporting mechanism in form of tariffs, EPA, IEA, nexus between the federal and provisional governments, distribution network for electricity distributor. He mentioned something about the market mechanisms should be available. Then local manufacturing, which is a very important aspect. We have been emphasizing this for the 2 day webinar, that transfer of technology of these turbines should be there. Direct investment and a partnership with the donor agencies should be done for future project development in this important sector. So thank you very much, Dr. Irfan Yusuf, for your very valuable presentation and very relevant presentation, I would say. So we now move over to question answer session. We have some questions from Nepal. Mr. Madhu Hituwal has asked few questions from Dr. Irfan Yusuf. He's saying that, have we observed any possibilities of increasing situation of spilling regulated flow from canal banks after installing series of turbines in cross section as well as longitudinal section in the designated canal system? I'm not sure that we have installed these turbines in this canal system, this much amount of turbines. But Dr. Saab, with your experience, can you very shortly or briefly touch this topic, this question, sir?
As you have very rightly pointed out that this technology has not been deployed in the country in a large way, as I indicated in my presentation. Pakistan has so far experienced crosswater turbines or Kaplan turbines for very small applications ranging from a few kilowatts to megawatts. But since this submersible turbine technology is not being deployed in canals, such I cannot share the experience of spilling of water in channels. However, this is very likely that if there can be the issue of spilling of water or banks stability issue while deploying this kind of technology. However, a proper design of turbines and taking care of all the parameters, technical parameters, can upfront can reduce such kind of risks.
Yes, thank you very much, Dr. Saab, for your elaborate answer on that one. So we have a question, same question from Mr. Madhu Hetowal, who has asked that who will be responsible for power evacuation from these projects, and please elaborate on the tariff ranges and agency responsible for PPA. So, with your experience, can you just briefly touch these topics? I'm sure there are no agencies responsible for these, since this is a very new technology. But you can just briefly touch the topic on this.
Yeah, as I indicated, there can be two interventions with regards to power evacuation. One is on-grid supply of electricity. If a power plant of more than 1 megawatt comes in and supplies electricity for the distribution, distribution companies are liable to offtake the electricity under commercial mode. They can buy the electricity from the power plant, and for that purpose, NEPRA is a regulator, a National Electric Power Regulatory Authority, who sets the tariff for sale or purchase of electricity. But for the purpose of distributed supply of electricity, that includes community scale, there is no set power purchaser. However, as different models being developed so far for microgrid installations using micro wind and some solar PV technologies, similar technological interventions can be made possible wherein the energy services companies can deploy the distribution mechanism for distributing electricity and sell to the nearby communities and serve their purposes based on tariff that's being negotiated with the community, and for that purpose concurrence of NEPRA is essential.
Thank you very much, Dr. Saab, for your elaborate answer. So, ladies and gentlemen, Mr. Dr. Shoaib Ahmed Saab would like to intervene and just comment on this previous question from Mr. Madhu Hetowal. Anybody from the participant want to share their opinion or their questions, they can raise hand or share their opinions also. So, over to Dr. Saab for this question from Mr. Madhu Hetowal regarding the siltation or spilling regulated flow from canal banks after installing series of turbines in cross section as well as longitudinal section. Please.
Well, thank you, Asen. Actually, I thought I should also share my whatever my experience or knowledge is in this regard. Mr. Madhu, your question is very valid, but I think first of all, it has not been studied, at least in the by the SARC Energy Center, because whatever we did, the work we have done as so far, we have that is based on only one turbine. So first of all, it has not been studied. Secondly, there is a very remote possibility of spilling water out of the banks, especially from the regular canals. It looks very remote. There are two reasons for it. First of all, because there is a distance between two turbines, and of course, if the turbines are also installed in an array of turbines is installed in the cascaded position, there is fairly good distance the speakers have recommended to be kept between that. Of course, they were talking about to minimizing the wake effect on that. But that distance, I think it is sufficient enough that in which whatever the speed of that water is reduced because of these turbines, that would be regained just because of the through the natural gravity. Okay, and the water would be again uh, regaining its original speed just by passing that distance. In case if there is any condition that you feel that okay, yes, this is becoming a real problem, in that case, I suppose the only recommendation would be that okay, uh, only recommendation would be that okay, increase the distance between the turbines. Uh, I think that would fairly resolve your apprehension in that regard, because this type of problem has not been, first of all, has not been studied in the by the Sark Energy Center. Never it has been. I have under my observation, it has not been reported in the literature as well. But that's only my personal views. Thank you very much. Thank you.
Thank you, Dr. Saab, for your nice reviews and your
ठीक है.
comment on the specific question. So with this, we have a lot of questions from the participants, and we feel that we are lacking behind the schedule. So we would quickly go on with, first of all, we would like to specifically thank Dr. Irfan Yusuf for his very nice presentation and for giving us time from his busy schedule, working in the ministry and getting time out of this for this webinar shows how enthusiastic and eager he is to contribute in this noble cause of supporting this technology. So Dr. Irfan Saab, thank you very much again for your very nice presentation, and thanks again.
Thanks to the Sark Energy Center and the listeners as well who have provided me opportunity to contribute and brief the participants about the prospects in Pakistan and the policy mechanisms. I'm really thankful.
So, thank you, sir. So now we would again. I have been informed that Mr. Nadeem Awan Saib might be online. So we would check him one last time if he is available. So if it's available, we would continue with this presentation. Otherwise, then we would move on to our knowledge sharing session. So, Mr. Nadeem Awan, I would now give the mic to you if. So we don't have Nadeem Awan Sahib online. I guess he's having some very troubles connecting with the system. Sometime problem like these technical issues arise, and you must all the participants must appreciate that it's very difficult to for some time to get all the experts online, and our IT team is continuously trying to get him online. If it's possible before the allocated time, we would definitely include his presentation in our session. So now quickly I will move on to our next knowledge sharing session. We specifically designed this session because we thought that if there are some questions which have been left over or which were remained unanswered, so we would like to address those issues, or we would like to comment on those question answers if they are left behind. So we have some questions from various participants, and anyone willing to reply on that one can raise their hand, or if he's interested he can reply back. So we have a question that if a private project developer wants to establish a localized distribution system making use of micro hydropower, are there any licensing regulations? So we would see if whoever is interested. So I think Dr. Irfan Yusuf, if he's interested. So Dr. Irfan Yusuf, would you be willing to reply to such question? Uh, am I audible to Irfan Saab? I
Yes.
think yes. Did you listen to my question, sir?
No, actually, no, I haven't listened. I was
Yes,
off
yes, yes.
screen.
I may like to repeat the question. We have a question from one of the participants. He has asked a question that if a private project developer wants to establish a localized distribution system making use of MHP, are there any licensing regulations?
Yes,
We specifically directed the question to you because we thought that you being a government representative of government body could answer this specific question correctly, sir.
yes, there are regulatory requirements. The, a company who is intended to establish a distribution network needs to get license for National Regulatory Authority of Pakistan, which is called NEPRA, for generation and distribution of electricity. Without this, it will not be possible for the company to carry out the business.
Thank you very much, Irfan Saab, for a very nice reply and very detailed comment on the specific question. So we have received one more question from Mr. Umar Mukhtar. He would like to ask, what are the tariff requirements for small hydro for private sector investment of an off-grid generation to be sold to local communities? So if Irfan Saab, you may like to respond to that question, sir.
Yeah, basically, it's all talks about the tariff mechanisms to be set in place. At the moment, there is no tariff announced by the regulator for such kind of interventions. But as per the policy mechanism available with the NEPRA, what a private sector company can do, it can work upon this cost analysis, and based on its cost analysis and the technical numbers of electricity units that can be generated, it can work upon a tariff that is suitable for an investor to generate electricity and sell it to the community. NEPRA has its own process for evaluating the costs and the energy numbers. After evaluating as per the process, it determines a tariff for such kind of interventions, and this tariff, if accepted or agreed by the company, can be made available to for the for undertaking this kind of intervention.
Thank you very much, Dr. Farsab, for your reviews and your comments on the specific question. So I may now, I think we are very much behind the schedule and we are having some difficulty still connecting to Mr. Nadeem Awan, for which we are very sorry, Mr. Nadeem Awan, for because of some technical issue we could not connect back to him. But obviously his presentation would be available at our website. Anybody wish to see his presentation can have a look at it, and if he has some specific questions, he can direct it to us, and we will definitely ask Mr. Nadeem Awan that specific question. Dr. Irfan Yusuf, we are very thankful to you for your very specific and relevant replies to the questions regarding policy and regulation aspect of the technology. We are grateful to you for joining us in this webinar, and due to being behind the schedule, we are going to finish this knowledge sharing session for now. The future questions would be directed to the expert in future through email, or anybody can text us or send us an email. Your recommendations are most welcome. You can give your feedback on our webinar after this gets closed. So, Dr. Fansab, thank you very much for you being with us, and we are grateful to you for supporting us in this webinar. Thank you, sir.
It's my pleasure for and really grateful for SAC for providing the opportunity. Thanks.
Thank you, sir. So, ladies and gentlemen, now we are at the very last session of our webinar, which includes the conclusions, recommendations, and the closing of the webinar. I have been assigned the responsibility to go through this session. So, we had some excellent presentations from many experts around the globe and South Asia region specifically. We had Dr. Nawaz Akhtar being the main expert of this study report. We are very thankful to you, sir. We have Umar Mukhtar, Mr. Ehsanullah Marwat, Dr. Shoaib Ahmad Saab for his time in attending this webinar. We are also grateful to Mr. Asif Farid from GIZ, Dr. Karl Komsi, Smart Hydro from Germany, Mr. Tommaso Morbiato, Wind City from Italy, and for Mr. Trey Taylor for providing us permission, for giving us permission to play his short interview of commercial aspects. Then we are also grateful to Mr. Malik Nadeem Awan and Mr. Irfan Yusuf, who joined us after the break on the sessions of business perspective and policy change challenges for this hydrokinetic turbines. We are grateful to each and every expert, and we are also grateful to all the attendees who spent their time listening to this fruitful discussion and this important technology aspects. Moving on to the conclusion side, I have note down some conclusions which we received from the participants, and we have also noted down these conclusions during the course of these 2-day webinar. So I am going to announce these conclusions one by one. One by one. The first conclusion came to us is that webinars are very effective in disseminating the knowledge sharing of this novel technology. So obviously we agree that webinars have been very effective in the very recent times, and we are going to conduct more webinars in future too. Then there was another conclusion that experience was instrumental by the researchers, by inviting the researchers and academia into this debate of policymakers and manufacturers. We always felt that the policymakers and manufacturers, the discussion should be involved with the researchers and academia also to collaborate and join hands in development of this important technology. Then we have a conclusion that the community scale projects under ESCO model for this technology could be beneficial in future, which is very rightly said, keeping in perspective of the micro hydro power success story in Pakistan. There's a requirement for awareness building and introduction of technology. Awareness building should be done on the government side and on the researcher and academia side too. Then we have another conclusion that canal water operator owners to encourage allowed for installation of turbines are renting out the water resource. A very important conclusion that canals operators should be allowed to do that, or for renting out their water resource and this one. Then we have another conclusion: utilities should be bound to offtake the generated electricity and subsequently sell it under green energy incentive. This is also very important that they must be bound to offtake all that generated electricity, which in case of Pakistan there is the provision included in the government policy, but other member states have also included this in their specific policies. Then there is another conclusion that foreign producers and manufacturers should be allowed to trial their products in SARC region. Testing facilities, we already heard something about the testing facilities before commissioning and after commissioning. So these things could be have testing laboratories in Pakistan or some kind of arrangement in that aspect. We have, for some limited time, the equipment of this technology should be waived of all taxes, duties and levies, which is very understandable that for a new technology to uptake in a market, some kind of incentives upfront should be given to that technology. So these were, ladies and gentlemen, these were the few of the conclusions which we had received from which we have gathered during the course of this 2-day seminar. Now I move on quickly to the recommendation side. Actually, these recommendations have been provided to us from the participants and from the experts of South Asia region, and also from the abroad experts who joined us during this webinar. So I will quickly read out all the recommendations one by one. So the first recommendation was that because of relatively low cost and durability of hydrokinetic turbines, including SARC member states can manufacture and implement the technology to supply the needed electricity to smart communities and villages. The second recommendation is that GIZ, which is a German development agency, should be requested to help out SARC Energy Center in the installation of different design concepts of submersible turbines for demonstration purposes on the Upper Jhelum Canal. And obviously this is a pilot study, so we took this study in Pakistan, but for sure the concepts also says that we have to replicate the same type of projects if successful in other SAARC member states. Then Mr. Karl Komsky may be invited to Pakistan to involve him in exploitation of the technology by arranging his visits to potential sites in Pakistan. Maybe some kind of international experts may be invited to are involved in the evaluation or finding of the potential for this technology in South Asian canals and rivers first. Then responsible government institutes should include the hydrokinetic submersible turbines in their list of renewable energy technologies. For example, in policies, renewable policies, solar and wind is included, hydro is included, but this technology needs to be included in their already designated renewable energy technologies. Further investigation or deployment of this technology to be carried out. And then responsible government institutes should make arrangement for assessment of resource potential in respective member state. A very interesting and important recommendation, which clearly states that before implementation of any project, assessment of resource potential should be carried out in all the South Asian countries. Then responsible government institutes should make awareness campaign for introduction of this technology in their respective countries. So then we have another recommendation that to popularize and boost interest in the installation of hydrokinetic energy projects, government subsidies may be allowed till the full utilization of this resource potential, which is very understandable and very relevant recommendation. Import duties and taxes, we have already talked about that one, that those should be levied for in first of the initial projects. So, ladies and gentlemen, we conclude this the recommendation and the conclusions are over for us. We would definitely I would once again announce that all the presentations and short interviews of this webinar will be uploaded on our SEC official website by Monday evening, maybe, because we would need maybe some time to gather the presentation from the experts. Plus, on top of that, if you need any assistance, any information you require, you can write back to us to specifically to our program leader, Mr. Dr. Akhtar Nawaz, or maybe you can also write back to our email address info@sarkenergy.org. You can also send us any recommendation, any advice you want to seek, or if you need to develop this technology in your country and you need assistance of SAARC Energy Center as an anchor between the manufacturer and your country, you can write back to us and we would be willing to help and facilitate you as much as possible. Plus, it was a wonderful experience for SAARC Energy Center conducting this webinar, and for your information and consumption of the house, this is one of the first webinar, but we are going to do more webinars in future. The upcoming webinar on difficulties for solar home systems in SAARC region will be held on 6th March of 2018. I would repeat, the next webinar of solar home systems would be held on 6th March 2018. Very soon you will get valuable information about the upcoming webinar on our website. Agenda will be uploaded and it will be information will be routed through the SAARC Secretariat. So any questions, any comments are welcome. SAARC Energy Center is there to help you and facilitate you as much as possible. So ladies and gentlemen, with this, I thank you all again for your patience during some technical difficulties and for also listening to this fruitful discussion by the panelists and the experts. I thank you again and God bless you. Bye.